Alright.
Rajiv here from Mathvybes.
Alright.
Today we're going to look at simultaneous equations. I am here with a student from Jamaica. Big up yourself. Tell everybody your name.
Alright, so my name is Demarley, and I'm ready to learn how to do the simultaneous equations because I'm not really seeing eye to eye with that.
All right, well, there we go. So right now I'm accepting Form 4 students. So if you're interested, feel free to message me via the number on the screen. So let me jump straight into it. So let me look at the concept. So what exactly is simultaneous equations? Simultaneous equations is when you have two or more equations involving two or more unknowns where the solution is a set of values that satisfying all the equations. Tell me, that's sounding like gibberish. That was just not reading that.
Yeah, kind of.
That's sounding like gibberish, right? The main thing I want you to take away is more than one unknown. So if you're seeing like X and Y or A and B, or you're seeing more than one thing you don't know, you have to use simultaneous equations. And when you solve it, it's supposed to satisfy the equations you come up with. So, Demarley, just keep that in mind, right? If you see more than one unknown, simultaneous equations. So let me look at scenario one.
All right.
Bob goes shopping for an apple. We're going to call the apple A and a mango M. After he purchased, he lost the bill. He doesn't know the cost of the apple or the mango. He just knows the cost, which is $15. Can he figure out the cost of the mango or the apple with this information? What do you think? You think he could figure out the cost of the mango or the apple?
Yes.
Nah, not in scenario one. Think about it, Demarley. If you buy an apple and a mango, right? And you lose the bill.
Yeah.
And you didn't know the cost of either one of them. You think you could figure out the correct apple?
No. I wasn't paying attention to the question.
So you would be guessing, right? You would be guessing then. You would guess, but you wouldn't know for sure.
Yeah.
Can you see what I mean when I say two unknowns or more than one unknown? I want you to identify the unknowns here. What are the unknowns?
The apple and the mango.
Yeah, we don't know what the apple or the mango is. So that is two unknowns. So what I'm saying is, two unknowns is trouble. One is enough. Fellas, I'm talking to all you. One is enough. Two is trouble. Two is trouble. Demarley, I'm not sure if you understand what I'm saying, but one is enough, right? So
yeah,
no matter what you do, you want to end up with one unknown. So I'm going to show you the concept behind substitution. So Demarley, in scenario 2, he remembers that the mango was 2 times the cost of one apple. Is the information enough now? Yes or no? You think so?
Not really.
Actually, it is. It is. So Demarley, we could come up with an equation here. And we know that the apple and the mango gonna cost $15 together.
Yeah.
So I can say E plus M is equal to 15. Yes or no? Make sense?
Yes.
Right? Yeah. I'm gonna call that equation 1. Now, in scenario 2, he remembers that I want you to read this for me. What is that saying?
He remembers that the mango was 2 times the cost of apple 1.
So in other words, the cost of one mango is equal to what?
Yeah. One mango is equal to 2 times 1. 2 times the first one.
That's what you're saying? That the mango is 2 times the price of one apple?
Yes.
Yeah, that makes perfect sense. Now, Demarley, the problem is 2 unknowns. And you're seeing we have 2 unknowns here and 2 unknowns over here. You're seeing that, right?
Yeah.
So what we're going to do carefully. And one mango is equivalent to 2 apples. Yes or no?
Yes.
So look at what I could do. I can make a substitution. I can plug it in into equation 1. And instead of writing M, I could write what instead? What could I write for M instead?
2.
2A, right?
2A, yeah.
Yeah, because one mango is also equal to 2 apples. So I made a substitution there. And so this will be equal to 15. And how much unknowns you see in here now? Tell me, how much unknowns you seeing?
1.
I see in 1. So, and I could solve for that?
Yeah.
Yeah.
So basically, what we're gonna do now is we're going to figure out A, right?
Right. So we have 1 apple and we adding on 2 apples to that, which is really the cost of mango, right? So if you have A
Yeah.
plus 2A, how much A's you have?
We have what, repeat, 1A plus 2A.
Yes.
So we have 3A.
Right. So 3A is equal to 15.
15.
And so if 3A is 15 and I want to find for A, I would have to divide both sides by 3. That makes sense, right?
Yeah, because whatever you do to one side, you got to do to the next.
Right. And so 15 over 3 is?
5.
Right. And just like that, we have the cost for the apple. So
Yeah.
I want you to understand what I just did there. I came up with an equation where the mango was in terms of the apple. And so I could make a substitution. And when I made this substitution, how much unknowns I end up with?
1.
Right. That's the goal. That's the whole goal. So we have E, let's find for M. Remember, nth the mango is 2 times 1 apple.
Yeah.
So I could plug that information into equation 2. So M is going to be 2 by 5. So the cost for the mango is $10. That makes sense?
Yeah.
Okay. Do you know how to verify if your answer is correct? Yes or no?
Yes. All right, let me take a guess. Would you like to it would be a case where you have to multiply the A by something else?
Nah. Simpler than that.
Simpler.
So we found A to be 5 and M to be 10. So if those are the correct answer, then it's supposed to satisfy this equation and supposed to satisfy this equation. Let me show you what I mean by that. So, Demarley, hence the apple plus the mango equal to 15. It's supposed to?
Yes.
Yes. So A plus M supposed to be equal to 15. And so, M, what do we find A to be?
1,
We found A to be 5. And what do we find M to be?
10.
Does that give us back 15? Yes, because 5 plus 10 is 15, right? So I want you to understand what I just did. If it's the correct answer, when I plug it in into the equation, it's supposed to satisfy the equation. You understand what I'm saying? Yes or no? Yeah, I'm not hearing anything.
So yeah, we found. Sorry about that.
Right? That's my issue. So what I was saying was, if you want to verify if the answer is correct, you could plug in your answers into the equations. And so we found A to be 5 and M to be 10. So if I plug that into this equation and it's correct, I'm supposed to get 15. Does it work out?
Yeah. Yeah, it does.
Let's try the other equation now. The other equation says that the cost of 1 mango is supposed to be equal to the price of 2 apples. So tell me, what do we find the mango to be equal to?
Found the mango to be equal to 2 times A. It should be 50.
No, what was the value? What was the value for the mango?
Or the 2 times the cost of an apple.
No, we found A to be 5 and M to be 10.
Oh, yes. Sorry about that.
Tell me if I'll lose you anyway. In any parts of this, did I lose you anywhere?
No, you didn't. It's just that I keep losing focus. Our focus in problem.
Ah, I see. So M is equal to 10, and that's supposed to be equal to 2 times the apple. We find the apple to be. Tell me, what did we find the apple to be?
Only up to the 5.
Right. And so we're saying that the mango is supposed to be equal to 2 times the apple. So if I multiply 2 by 5, am I getting back 10?
Yeah.
Yeah. So did my answer satisfy both equations?
Yes, it did.
So that's how you check if your answer is correct. So that's the whole concept behind substitution. That's it.
Yeah.
Let me show you
I understand that.
let me show you the concept behind elimination. So you understand that the problem is 2 or more unknowns. So if we could get one unknown, we could solve it. So in elimination, we want to get rid of one of the unknowns. So a simple example is, if you remembered that the mango was $10, and you could figure out the price of the apple, yes or no?
Yes, you can.
So if, remember, both the apple and the mango was $15. And so if he remembers that the mango was $10, and he could easily find for A.
Yeah.
So I would say A plus 10 because he remembers that the mango was $10. And so if I want to find for A, I would just subtract 10 on both sides. So A would be equal to 15 minus 10. Tell me if I confuse it there.
No, you didn't.
So there are multiple ways you could think about it. And I'm going to show you all these ways you could think about it. I see in 2 Demarleys.
Yeah, I just learning on another device because I can't use this one. Since the audio is low, so I joined on someone that can hear better.
Okay. So you have multiple ways you could think about it. You could think about it like this. You're moving across the positive 10. If you're moving across something, the sign changes. That's one way you could think about it. And so A would just be equal to 15 minus 10. The other way you could think about it is you're just subtracting 10 on both sides. And so the plus 10 and the minus 10 will cancel off.
So it's like the same rule that I was saying earlier.
Yes. And so anytime you want to make something the subject, you just work in reverse. You're literally just working in reverse. So if you're adding 10 to A and you want to find for A, you need to subtract 10. And so A would be 15 minus 10, so A would just be equal to 5. And isn't it common sense? If you know everything costs $15 and the mango was $10, and obviously the apple will be $5 because 5 plus 10 had to be 15. Yes or no?
Yes.
Right. So
I was just doing it on my papers just to make sure.
All right. So in elimination, we get rid of one of the unknown, and in substitution, you're making an equation and you're plugging that into the other equation. So that's the basic gist of it. Let's do an actual question. So I'm going to run through the substitution method first, and then I'm going to show you the elimination method. The elimination method is the best method to use for linear equations. Do you know what linear equations are?
Yeah. Could you give me a quick definition?
Okay. Let me just say I have these two equations. Like, let me just say I have A plus B is equal to 9 and A plus 2B is equal to 3. Are you seeing any powers? Yeah. Are you seeing any powers?
No.
If you're not seeing any powers, that's the simplest way I could tell you is a linear system of equations. If it had, let me just say it had 2 over there, it wouldn't be linear again. That would now be quadratic. So, if you're not seeing a power, linear.
Yeah.
You're seeing a power, non-linear.
Okay.
Right. So once is a linear system of equations, elimination is the easiest method, but still showing you substitution.
All right, because my teacher didn't show me these 2 methods.
That's very interesting. These are the 2 methods, and there's also the matrix method, but you typically don't.
I only learned one method and it was substitution. So I kind of understood when you were talking about it, but elimination, I didn't really learn that.
Okay, you're gonna be mind blown when I share elimination. So stay with me, you're gonna be mind blown. So here what? In this question, we have a pen and a pencil. Together they cost $12. So let me just call the pen P. So the pen is P, and let's call the pencil C. So the first piece of information, they are telling us that the pen P and a pencil C is equal to $12. Yes or no? You understand how I do that?
Yeah.
Right. The other piece of information, they're telling us that two pens, so 2P plus one pencil is equal to 19. And we could call that equation 2. So you're with me so far?
Yeah.
In the previous example, did we have to make an equation 3? Or was there already something that could have used to make a substitution?
We already had something that we could use to make a substitution.
Right. So let me explain how to do. I want you to pick an equation. You could pick any equation you want. You want to pick one or two?
Let's start with one.
Okay. And in one, what do you want to make the subject of the formula? You could either pick, it doesn't matter.
Can make the pencil.
So you want to make C the subject?
Yeah.
Okay, we could do that. And so if I want to make C the subject, I'm going to move across everything that is not C. So should the P be over here?
No, it should be over where the 12 is.
Right. So I would write P plus C is equal to 12, and I would move across the P. Now, if I'm moving across something, the sign changes. And think about it. If you want to get rid of P, wouldn't you have to subtract P on both sides?
Yeah. So they cancel out each other.
So C would be equal to 12 minus P. Yes or no?
Yes.
And I would call this my third equation. So why is this important? Remember, if you have two unknowns, you can't do anything. You can't do a single thing. But if you have one, it's very simple. And so we know what the pencil is in terms of the pen. I want you to understand that. We know what the cost of the pencil is in terms of the pen. So, in other words, a pencil is just 12 minus the cost of a pen. Understand?
Yeah.
And so I can now take this and plug it into equation 2. So you see how you use equation 1 to make equation 3? You cannot plug it into equation 1. You need to use the other equation you didn't use.
Okay.
So I'm going to write down the steps. From equation 1, make equation 3. But you could have used any equation to make equation 3.
Okay, so it doesn't really matter.
It doesn't matter. I'll show you another case. Right, so from equation 1, make equation 3. And we didn't use equation 2 yet, so we're going to plug equation 3 into that. So, plug. Right. So what do I mean? Anywhere you see C over here, we're going to replace it with?
We're going to replace it with 12 minus P.
Right, because that's what C is equal to. That is what C is equal to. So we have 2P plus C is equal to 19. And we know that C is 12 minus P. So that's why we call it a substitution. Right?
Okay.
I would advise to put it in brackets. Put it in brackets because it's a binomial term. Do you know what a binomial term is?
No, I'm not familiar with that term.
So bi means two. So integrate C, you have two terms here with a minus sign in the middle. So
Yeah.
you're not 12 and you're seeing a P and you're seeing something in the middle. That's what binomial means. It's basically an expression that's made up of two terms. I would advise put that in brackets. Put that in brackets. and that's equal to 90. So you understand, all I did was I just replaced C with 12 minus P. Simple?
Yes. Yes,
Right.
simple.
And so now I could drop the brackets. Now, since there was a positive sign on the outside, I'm not going to change the sign for anything on the inside. So I'm just
Why
going
is that?
to ask that question. What's a positive by a positive?
A positive,
What's a positive by a negative?
negative,
So watch. If I multiply everything on the inside by plus 1, where's plus 1 by 12?
that's 12.
If I multiply plus 1 by minus P, what was that?
Minus P.
Right, so you see that nothing changed, right? Nothing changed.
Yeah.
But if this was a negative sign now, you would have had to say negative 1 by 12, negative 12, and negative 1 by negative P is plus P. Understand?
Yeah.
So you have
Yeah.
to, that's why you need to put your brackets. And so you're going to end up with plus 12 minus P is equal to 19. Right, so now you want to group together the like terms. So some like terms here would be P. So I have 2P minus P. Imagine you have two pencils. No, P is pens, right? P is pens. If you have 2 pens and you take away a pen, how much pens you have?
You have 1 pen.
Right. So 2 pens minus 1 pen, that just leaves you with 1 pen. Simple enough, right?
Yeah.
And I have the plus 12 here, and that's equal to 19. So I want to find for P. I want to find for P. I want to find how much 1P is equal to. So right now, I have 12 being added to P. So to find for 1P, I would have to subtract 12 on both sides, or just simply move across the plus 12. And so 1P, do you understand how 1P is the same thing as P? Yes or no?
Yeah, I understand that.
And so P is going to be equal to 19. What am I going to say? 19 what?
Huh?
I'm going to say 19 what?
19 pencils?
No,
Pen, sorry.
take your time. It was 1P plus 12 is equal to 19. And so I wanted to find for P. So I had to move across the 12. If I move across the 12, it's going to become what?
Oh, minus 12, sorry.
Right. And so P is going to be equal to, what is 19 minus
So that would be
7, right?
7, yeah.
Right. So that's the cost for 1 pen. Let me ask you this.
All right.
How are we going to find the cost for the pencil now? Do we have any equation telling us what the pencil will be equal to?
Yeah, the pencil would be equal to 12 minus P.
Right. Remember, C is equal to 12 minus P. So if I wanted to find the cost of the pencil, I would say 12 minus what? What do we find P to be?
7. So,
Right. So C is equal.
so 5.
Right. How do you find ours?
Huh?
How do you find ours?
Sorry, I didn't hear that. Can you say it one more time?
How did you find ours? It was easy, hard?
Oh no, it wasn't. It was all right. I understand.
So do you know how to check if your answer is correct now? From the previous question, let me see if you remember. How would you check to see if your answer is correct?
You're gonna plug in the value for P and C and check it.
Right. So let me plug it into equation 1. So Demarley, if I plug P and C into equation 1, what is it supposed to be equal to if it's correct?
Supposed to be equal to 12.
Right. So we found P to be 7 and we found C to be 5. Is 7 plus 5 equal to 12?
Yes.
Right? So we good? Let's try over here now. So 2 by 7 plus 5. That's supposed to be equal to 19. Just verify that.
Yes.
Right. So that's how you check if you're correct. So can we confidently say we are correct?
Yes, we can.
Nice. But that's not the only way you could have solved the question. I believe it's important to understand the full concept and how to change up things. Because in maths, it will always stay the same. So here what? Let me change up something. The last time we used equation 1 to make C the subject of the formula. I want you to change up things a bit. Change up things.
All right. So this time, want to use equation 2.
Okay, we could use equation 2, right? So we're going to say use an equation 2, make equation 3. And what do you want to make the subject of the formula in equation 2?
All right. You can make it the 2p this time.
We could make 2p the subject, but you would have to make p the subject. You'd have to make p. And let me do that. That's a harder example, but it will work out. So you're saying you want to make p the subject of the formula?
Yeah.
Okay. So we have 2p plus c is equal to 19, right?
Yeah.
I want to make p the subject. So what doesn't belong on the left-hand side then? I want to make p the subject. What does not belong on the left-hand side?
The 2?
No, the 2 is merged with the p.
So the c then.
C. So what would I have to do with the c then?
You have to subtract it.
I would have to subtract c on both sides, right?
Yeah.
Or in other words, I could just move across the c, and if I move it across, it's going to turn to negative c, right?
Yeah.
So 2p is equal to what?
C minus 19.
No. Did we move across the 19?
Oh, no.
You just now said minus 19. What did we move across?
The c.
So correct yourself. It should be what? 2p is equal to?
19 minus c.
Right. So that is what 2p is equal to. Do I want to find for 2p or do I want to find for p?
So now you're going to get rid of the 2?
Right. So right now the 2 is being multiplied by the p. So I want to find for 1p. So what would I have to do with 2p to find for 1?
Divide.
I'm going to divide that by
2.
Right. And I'd have to divide this by 2 as well. Understand?
Yeah.
So p is equal to 19 minus c all over 2.
Yeah.
And that's equation 3. Now, in this time, since you use equation 2, can you plug that into equation 2?
Yes.
No. Remember, whichever equation you use to make equation 3, you can't use that again.
Oh.
So we're going to plug it in into equation 1 this time. So plug equation 3, equation 1. So understand what I'm saying, right? If you use 1 to make equation 3, you can't use that again. If you use 2 to make equation 3, you can't use that again. Hope you understand that.
Yeah.
So now, in equation 1, anywhere I see p, what am I going to replace it for?
19 minus c over 2.
Right, and I'm going to put it in brackets just to be safe. 19 minus c all over 2. Tell me what to write. Yeah, 9. So what I just now did was, instead of writing p, I wrote 19 minus c over 2. What to write next? Tell me what I should write next.
So you should p plus c equal to 12.
Wait. What is p equal to?
Oh shoot. No, sorry. It should be plus c equal 12 now.
Right, because and this whole thing is p.
Yeah.
Yeah, that whole thing is p. right? Plus C is equal to 12.
Yes.
Things looking a little complicated here, and
Yeah.
things looking a little tough. But don't get scared, it's not hard. Do we like working with fractions?
Not really.
No,
Not really.
I don't really like
But
working with fractions myself. So if I wanted to get rid of the 2 in the denominator, what do you think I could do throughout?
uh um I'm guessing you should find the lowest common multiple.
Yes. But
Oh, yeah.
since we have one fraction, you could just you know how to do that. You know how to do that. If you have 2 fractions in the equation here, but you just have one. And so you have 19 minus C divided by 2. So what's the opposite of divided by 2?
Multiply.
Yeah, so you should probably multiply everything by 2. And why am I saying
Okay.
watch? If I multiply this by 2, what's going to happen?
They're gonna cancel, so you're gonna have 19 minus C.
Right. So I'm going to have 19 minus C, right? And I'm multiplying everything by 2. So that's going to turn to what?
Plus 2C,
Right. And that 12 going to turn to what?
24.
Right. Lovely. On the left-hand side, let's look to simplify. Are there,
All right.
are there any like terms on the left-hand side?
Yes. The C and 2C.
Right. So if you have trouble with directed numbers, like positives and negatives, you could just use a calculator, right? So let me show you what I mean. So you have minus C. That means minus 1 plus 2C, so plus 2. And that's just equal.
Okay.
Minus 1 plus 2 is just 1,
Yes.
right? Minus 1 plus 2 is 1. So that minus C plus 2C is going to turn to what?
C
Right, so I'm going to write 19 plus C,
plus C equals 24.
and I want to find for C. So I need to move across what?
The 19.
If you move it across, it comes like you're subtracting 19 on both sides, and it's going to become C equal to
19 minus 24.
no, take
Not
it
24 minus 19.
24 minus 19, right?
Yes.
And 24 minus 19 is what?
Let me do that real quick.
Right, that should be 5.
5. Yes, 5. I'm a bit slow on that because I don't got a calculator on.
That is okay. That's okay. Right, so we have C is 5. Did we get that last rounds? Did we?
Yes.
Yeah. C, no matter which way you do it, you get the same answer once you do the maths correct.
Yeah.
So C
I
is,
find the elimination way a bit easier, to be honest.
say that again?
I find the elimination way a bit easier.
Yeah, you're going to see that the elimination method is so much easier than this. Like
Yeah.
infinitely easier. So here what? We have C is equal to 5. And so which equation would allow us to find for the other unknown?
The equation 2.
Now equation 3.
Yes, equation 2. Sorry.
Equation 3 is telling us what P is equal to. So P would be equal to 19 minus C all over 2, right?
Yes.
And so what did we find C to be?
5
So I'm going to say 19 minus 5.
minus 5 over 2. Yeah.
What is 19 minus 5?
That's 7. Not 7, 14, sorry.
You tell me
Sorry.
it's here. You cannot jump ahead there, right? Because 14
Yeah.
is 7.
Yeah, so P is equal to 7.
So let me ask you a question. Is that the same answers we got when we did it last time?
Yes.
Yeah. So let me recap, right? When you're doing this method, you're gonna come up with 2 equations at the start. See, if it's a worded question, you might have to read it and you'll have to come up with the equations. Understand?
Yeah.
Then you're gonna pick one of the equations and you're gonna make one of the variables the subject. Yes or no?
Yes.
If I use equation 1, can I use it back again?
No.
No. If I use equation 1 to make equation 3, I'll have to plug in equation 3 into equation 2. If you made equation 3 from equation 2, can you plug it back in into itself? Or you would have to use equation.
Yes.
Now, I tie you up there. Here what I'm saying, right? If you use equation 2 to make equation 3,
Oh no.
can you use it?
No.
You can't, right?
No.
Can't use it again.
Yes.
And so from there, you plug in equation 3 into the other equation, and you would
Mm-hmm.
have to find for the other unknown. That's it. Once you
All
find
right.
the unknown, you're going to plug it into equation 3 because equation 3 will tell you what the other unknown is equal to. If you don't believe me, watch. And it's telling us P is equal to 19 minus C over 2.
Yeah.
The last method is the same method, it's just we're using different things. In the last one, and it told us that C is equal to 12 minus P.
Mm-hmm.
Yeah, so when you find for one of the unknowns, you're going to plug it into equation 3. So that's it for substitution method. Show you the
Yeah.
elimination method. You're going to be mind blown here. Your brain going to implode. You're going to be, wow. So just remember, what are the equations? What are the equations?
P plus C equals 12.
What are the other equations?
And 2P plus C equals 19.
So in the elimination method, as the name suggests, you want to eliminate one of the
Equations.
no, the unknowns. You want to eliminate one of the unknowns.
Yes, the unknowns.
Remember what I tell you? 2 unknowns is trouble. 1 is enough. Now I don't know you. Yes, I'll play boy, but 1 is enough. One
Yeah.
is right. So, are you a playboy? Are you a player?
No.
Nah? Okay. Then they should be good in simultaneous equations and 1 unknown. So, look at what I'm going to do carefully. In elimination method, you want to make sure the coefficients are the same, so you can either subtract them or you can add them. So look carefully. I'm going to say P plus C is equal to 12, and I'm going to put 1 underneath it. So 2P plus C is equal to 19.
Yeah.
What could I do with these 2 equations? I could cancel off one of the unknowns. Should I add the equations? Should I minus the equations from each other? What do you think I should do?
Add them.
No. If I add them, it's not going to work out. Watch. If I add them, P plus 2P is what?
3P.
C plus C is
2C.
12 plus 19. That is 31. How many unknowns we have?
So now,
That didn't help.
oh,
Not help. That's all. What we should have done is minus. Why? Why should we minus? It's because I have plus C over here and I have plus C over here. What is plus C minus plus C? Or in other words, what is C minus C?
C minus none, 0.
Yeah. And NT could only solve it when you have 1 unknown.
Yeah.
Yeah, so let me see what happened. What is P minus 2P? P minus 2P.
Plus P.
That'll be negative P.
Or negative P. All right.
Is that confusing? Yeah, tell me. Some of that confusing.
It's not confusing. It's just as I said, it was a focusing problem. I just realized what you're saying.
Do you have ADHD as well? I have ADHD. Like
Yeah.
I used to take medication for it.
It's not really that bad, but like sometimes it's because like it's not all the time. It just attacks me sometimes.
That's sometimes kind of thing.
Yeah.
So what I'm saying is minus 2P is equal to minus 1P. Look at where the negative is. Is it negative by the bigger number, by the smaller number, or the bigger number? Where is the negative by?
The bigger number.
So you're going to get a negative answer, right?
Yeah.
And if you're confused, just use a calculator. Watch. So P is 1. So 1, right?
Mm-hmm.
P, which is minus 2, a minus 1. So it's minus P.
Okay.
What is C? Look at this carefully. It's going to be plus C minus plus C. What is C minus C?
Nothing.
0, right? Or
Yeah.
I could just write nothing, right?
Yeah.
And what is 12 minus 19?
-5.
No.
Negative, no, no, -5. Negative. What's that? What's that?
So,
It's a six.
in other
It's
words,
a six.
negative P is equal to negative 7. So, if
Yeah.
negative is equal to negative 7, what would P be equal to?
P would be equal to -7.
So, let me blow your mind for a second. If I overlap this with this, what does P take any place of? What
The
is
7.
7? So, P is 7.
Yeah.
Another way to think about it is you're trying to find for P, right? And so you would need to get
Mm-hmm.
negative sign. To get rid of the negative sign, and you can multiply both sides by -1. Yes or no?
Yes.
Yeah, because what's a negative by a negative?
A positive.
Right. So just like that, we got the answer for P. That was real simple. And so now
Yeah.
I want you to pick an equation, and we're gonna plug that into the equation to find for. You can pick anyone this time. You can pick anyone in one this time to find for.
We can pick let's go with equation 2 again.
Okay. So what we're gonna use equation 2, right? So using so if I use equation 2, what am I gonna plug P as? Do we know what P is equal to?
Yes, 7.
So I'm going to say 2, open bracket, 7, plus C is equal to 19. What is 2 by 7?
14.
So I'm going to write 14 plus C is equal to 19. And
Yeah.
so if I want to find for C, I'd have to move across what?
14.
If I move it across, it's going to turn to what?
Minus.
So tell me what to write.
So it's going to be equal C equals 19 minus 4.
And that would be equal to,
5.
and that's it. That was so much,
Yeah.
right?
Way simpler.
That's the limit.
That's
Yeah. And
I thought that too.
and if you want, you could use equation 1 too, using equation 1. And if we use an equation 1, remember equation 1 is P plus C is equal to 12. And so 7 plus C is equal to 12. So C would be equal to what?
So C will be equal to 7 minus 12.
No, take your time. Correct yourself. Correct yourself. You said 7 minus 12. That's incorrect. What should it be?
Oh, 2 times 7. Sorry.
What is 12 minus 7?
That is 5.
You get the same answer. Could use any.
Yeah.
And so we got P to be equal to 7 and C to be equal to 5. Is that
Yeah.
what for substitution?
Yeah.
Yeah. So no matter what you do, you get the correct answer.
I find elimination easier and it's shorter too.
It's a lot easier. Trust me, it's so much easier. And let's look at it from another. Let's Okay, so you see in this instance, what did we eliminate? Which unknown did we eliminate?
We eliminated C.
C. We eliminate C. You think we could eliminate P?
Yeah, we can.
Yeah, I'll show you how to do that. So remember the equations. Let me just place it here. All right. So I'm going to write that back. I'm going to write P plus C is equal to 12.
Yeah.
2P plus C is equal to 19. Now, let me ask,
Mm-hmm.
if I add p and 2p, I'm going to get what?
3p.
Did it cancel off?
No,
No. If I minus p minus 2p is what?
just p.
Did it cancel? No, it's minus p. Say it correct. Minus p. Minus p.
Yeah.
Did it cancel off?
Yes.
No. If it
No, no.
if it cancels off, it gets eliminated, meaning you don't see it at all.
Oh, yes. So like with C, like with the C earlier.
Yeah, yeah. With the C, where did it go? It just vanished, right?
Yeah, just
But if I minus, I'm still gonna end up with P over here. So that's not really helping, no? So what do you think I should do then? If I want this and this to cancel off, what do you think I should do with this equation?
so I'm assuming
Because
one.
I want this and this to be the same. So you see how I have 2P over here?
Uh-huh.
I want to get 2P over here so I could minus it so it would cancel off from each other. So what do you think I should do with this equation? If I want to get 2P over here?
Multiply it by 2.
Yeah, exactly. So if I multiply that equation by 2, it's now going to turn to what?
2p plus c.
No,
E.
you do something,
2p plus 2c.
right? Equal to,
24.
all right. And I wanted to look at that new equation. And
Mm-hmm.
could I now add or minus to cancel off?
Yes.
So if I have 2P and I have 2P, what would I have to do with that so it will cancel off?
Minus.
Minus. So what is 2P minus 2P,
Nothing.
right?
0.
What is 2C minus C?
C.
What is 24 minus 19?
That's 5.
Bam, you get the answer one time. C is equal to.
Yes.
And
Mm.
which equation do you want to use to find for P?
Or you can use equation 1.
Right? Using. Okay, so so equation 1 was P plus C is equal to 12. So I know what C is. So I'm going to say P plus 5 is equal to 12. And so if I want to find for P, I'd have to move across what? If
The 5.
I move it across, it's going to become,
E equals 12 minus 5.
right. What is 12 minus 5?
That's 7.
Just like that, we get both of the answers.
Yeah.
Yeah. Very easy.
Yeah, it's easy.
So let's do a second example, right? And I feel like I wanted to learn the elimination method because it's much more error free. Like you're a lot less prone to making errors. So I'm going to show you the elimination method first, and then I'm going to show you the substitution method for the second example. So,
Yeah.
you're right. Just by looking at this, if I add or I subtract these two equations, are they going to cancel off? Are they the same?
No.
I want you to pick something to cancel off. I want to cancel off X or Y.
Yeah, and so X.
Okay, if I want to cancel off X, right? X. Then what do you think I should do? Let me hear.
Multiply by 2.
Which one? The top one or the bottom one?
The bottom one.
If I do that, what will I end up with?
2x plus 4y plus 60.
Nah,
Equals 60, sorry.
70. 70.
Not 70.
Right. So look at what I'm going to do, right? I'm going to write back the first equation. So that's 2x plus y is equal to 40. I'm going to write back this new equation that came from equation 2.
Mm-hmm.
And so what do you think I should do with those two equations?
You're gonna subtract
What is 2x minus 2x?
0.
What is y minus 4y?
Negative 3y.
What is 40 minus 70?
Negative 30.
Right? So you have negative 3y is equal to negative 30. And so if you wanted to find for y, you would have to divide both sides by,
Negative 3.
right? Because I want you to cancel off there and there. And so what is minus 30 over minus 3?
That would be 10.
Correct. That would be 10. Lovely. So we have y. I want you to pick an equation to use to find for x now. Pick an equation.
Can use the second equation. X plus 2y equal to 5.
Right, so let me just label this. This is 1. Okay, this is 2. Right, so using, which one you wanted to use? Use an equation.
Using the second equation, x plus 2y.
Right. So the second equation is x plus 2y is equal to 35. Do we know what one of the unknowns are?
Yeah,
Yeah.
we know what is y. So the new equation will be x plus 2 times 10 equals 35.
And so I want to find for x. And so what should I do?
You're going to move the 20 over to the other side.
And so x will be equal to,
When 35 minus 20,
and that will be equal to,
15.
and if that's the correct answer, it should do what to both of my equations?
You're going to plug in both values.
I want you say satisfy both equations. That's the proper way to say it. So if that's correct, it's going to satisfy all the equations. So pick an equation to try it with. 1, 2, or 3.
Let's try it with equation 3.
Equation 3. Okay, the equation we came up with. So
Yeah.
what was x?
To 15
What was y?
or 10.
So if I'm correct, when I work that out, it's supposed to be equal to what?
70.
Let's see. What is 2 by 15?
30.
What is 4 by 10?
40.
Will that give me back 70?
Yes.
So are we correct?
Yes, we are.
Yeah. That's it?
Uh-huh.
Easy,
Have
right?
a try with equation 1.
Okay, no problem. We use equation 1. So you could say using equation 1. Wait, you wanted to plug it in into equation 1, or you wanted to solve for x using equation 1?
No, I want to plug it into equation 1.
Okay, so x is 15, y is 10, and if we correct, what we work that out is supposed to be equal to what?
40.
2 by 15 is 30. 30 plus 10 is in fact 40, so we correct. Nice.
Oh, yeah.
100%
Yeah.
correct.
Just wanted to make sure.
That's good. We are 100% correct. So you understand the elimination method, right? Nice, right?
Yeah.
Okay. Let we do it using the substitution method, and you go appreciate the elimination method. So
Right?
we're gonna call this equation 1. Gonna call this equation 2. Which one you wanna use to make equation 3?
Equation 1.
And where you wanna make the subject, x or y?
Let's make x a subject.
You're going down the hard route.
Yeah, because I want to make sure I understand it properly.
Okay, that's fine. So using equation 1, make equation 3. So we have 2x plus y is equal to 40, and I want to make x the subject, right? So what if we want to make x the subject? Remember, the 2 is tied to the x. So you can't do anything with the 2 just yet. What shouldn't be on the left-hand side? What should not be on the left-hand side?
The y.
So I should move it across. And so
Yeah.
2x will be equal to,
40 minus y.
and I have 2x. I want to find for 1x. How would I find for 1x?
Divide.
Yeah, I would have to divide both sides by 2.
Yeah.
X would be equal to,
40 minus y over 2.
and that is equation 3.
Yeah.
You know what? Since you use equation 1 to make equation 3, you're not going to use it again. You're going to use equation 2 now. So you're going to plug equation 3 into
equation 2.
right. So anywhere I see x, I'm going to write what?
40 minus y over 2.
Right. Don't forget to put brackets. We're being extra safe here. You're probably wondering, why am I telling you to put brackets? I'm telling you to put brackets because what if you had something on the outside? Let me just say instead of x over here, you had 4x. Then wouldn't it be 4 by 40 minus y all over 2? Yes or no?
Yes.
Yeah, so you need to put your brackets. It don't look important, but it's very important.
Okay.
So you understand, all I'm doing here is just replacing x for 40 minus y over 2. Because that is what x is equal to. X is the same thing.
Yeah.
Right. What should I write next?
Plus 2y equals 35.
Do I like working with fractions?
No.
Oh, so in that equation, I have 40 minus y being divided by 2. So what do you think I should do on both sides?
We're gonna multiply
Multiply both sides by what?
2.
Understand the 2 and the 2 would I cancel off here, right? So it's just going to be what?
Yeah. 40 minus y plus 2y equals 70.
Be very careful. Whatever you do in one place, you have to do it everywhere. Everywhere. So that y is supposed to turn to what?
4y.
That 35 is supposed to turn to?
70.
Right. What do you want to make the subject here now? We want to find for?
We want to find for y.
Right. So you have negative y plus 4y. So that whole thing going to turn to what?
3y.
Right. Right. And you want to find for y. So what? Remember, the 3 is kind of locked in with the y. So you can't do anything with that just yet. But what can you move across?
The 40.
Right. And so that's going to turn to 3y.
3y equals 70 minus 40.
And so 3y is equal to?
30.
And if 3y is 30, then to find for 1y, I would divide both sides by 3.
So y would be equal to 10.
Right. And as the same answer we got last time?
Yes.
Right. Yeah, watch. Y is 10.
Mm-hmm.
Y, how would I find for x?
For x would satisfy the equation.
We want to find for x.
With the y?
You do these you check to see if it satisfies once you have x and y, but we don't have x just yet. So which equation am I going to use to find for x? Which equation is telling us what x is equal to?
Equation 3.
Yes, and equation 3 is telling us that x is going to be equal to 40 minus y over 2.
Yes.
All right, so we're going to say using equation 3, find for x. So remember, x is equal to 40 minus y all over 2.
Yes.
And so we know that y is 10. So that's going to be 40 minus 10 all over 2. 40 minus 10 is?
30.
Right, and 30 all over 2 is,
15.
was that the same answer we got when we did the elimination?
Yes.
Yeah. So these are your solutions. And obviously, it's supposed to satisfy the equations, right? So
Yeah.
to get into equation 1, that's going to be 2 by 15 plus y, which is 10, and that's supposed to be equal to 40. Right? 2 by
Yeah.
50, 30 plus 10. Yeah, so works out. And you choose the harder route. If you wanted, you could have made y the subject very easily, and y would have been equal to 40 minus 2x. So I'm gonna show you that method as well. I think we should probably do that to be thorough. Duplicate. And by chance, did you learn about the graphical interpretation of this? Like the intersection.
No. No.
Okay, we'll cover that here, right? We'll cover that here. So here what? We're gonna try to make y the subject this time, right?
Yeah.
Okay, so I have 2x plus y is equal to 40. So using, and by the way, could I use equation 2? Could I do it anyhow you want? Using equation 1, make equation 3. So we're going to make y the subject this time. So I'm going to speed run this. So 2x plus y is equal to 40. If I want to make y the subject, what do I do?
I'm gonna get rid of 2x.
Right, so I'm going to move across 2x. So that's going to become what on the right-hand side?
40 minus 2x.
Right. And so that's equation 3. And so where am I going to plug that in?
Gonna plug that into equation 2.
Right. Right. And so anywhere I see y in equation 2, what am I going to replace it with?
40 minus 2x.
Now, let me show you why you have to be careful. Remember, by the way, this is an example of what expression starts with b. I told you it earlier. It's a
Binomial.
binomial. B,
Yeah, binomial.
meaning that there are two terms making up this entire expression. And so
Yeah.
you should put brackets. And you're going to see why putting brackets is important. And that is 2y.
40 minus 2x.
Watch, but isn't it 2 by y?
Oh,
And so watch, I need to put the 2 on the outside, and I'm going to write what y is on the inside.
so 40 minus 2x.
And that'll be equal to,
That will be equal to 40.
no, 35.
Not to 35.
Remember, we're plugging that into equation 2.
Yes.
So I wanted to observe carefully what happening, right? What did we say y was equal to? Y was equal to what?
40 minus 2x.
Right. So anywhere I see y, I'm going to write what?
40 minus 2x.
Now, over here, write back the x. But you notice it's 2 by y. So wouldn't that be 2 by this whole thing over here? Because doesn't this whole thing, what does this whole thing represent? And y, right?
Yes.
You need to put that in brackets. And in the next line, you have to expand. You know how to do expansion?
Yes, to some degree.
Okay, so you see how we have 2 on the outside? Positive.
Yeah.
We're going to multiply everything on the inside by positive 2 to expand it out. So you're going to multiply positive 2 by 40. You're going to multiply positive 2 by negative 2x. So what is 2 by 40?
80.
What is positive 2 by negative 2x?
Negative 4x.
Right, and that will be equal to 2. So you want to find x. So we have x and we have negative 4x. So what is x negative? What is x minus 4x?
3x.
negative 3x, right? Negative 3x plus 80. Did I confuse you?
No, you didn't.
Okay. And I want to find for x, so I need to move across what?
You need to move across the three.
No,
No.
but this is
The eight. The 80.
that's
The 80.
part of the x term. You need to move across the 80. And if I move across the 80, it's going to become what?
Negative 3x equals 35 minus 80.
Right. 35 minus 80, that should be 45. Yeah, minus 45. Minus 45. And so if I want to find for 1x, I would have to divide both sides by,
Negative 3.
right? And negative 3 into negative 45, that would give you 15.
Yes.
Did we get that last time? X is equal to 15.
Yes.
Nice. And so which equation am I going to use to find for y?
For y, we can use equation 2.
No, remember, you could use equation 2. I'm not saying that you can't. You could use it. Oh, but equation 3 smartest play. Why? Try to figure out why I'm saying that. Why am I telling you to use equation 3?
Because equation 3 already gave us the answer for y.
Exactly. You wouldn't have to do any work in because it already telling you what y is.
Yeah.
So it's more to write. So remember, y is equal to 40 minus 2x. So y would be equal to 40 minus 2 by
what was x again? Yeah, 15.
so that'll be 40. 2 by 15 is minus 30. So y is equal to 10.
Okay.
And notice I'm getting the same answer no matter what I do. If you do it correctly, you'll get the same answer no matter what you do.
All right.
Yeah.
Understanding.
But observe how much simpler the elimination method was. Look how simple this was.
I prefer the elimination method better than the substitution one.
But I want you to understand both to a good degree. Understand both to a good degree, right?
Yeah. Yeah, I'm making notes, so I understand.
I will send you this after, right? I will send you this after.
All right.
So you said you never looked at the graphical solution.
No, it's the first time I'm hearing that you could use graphs to find it.
Let me ask that question. Aren't you doing coordinate geometry?
Huh?
Aren't you doing coordinate geometry?
Yes.
And
But that, as I said, that's one of the topics that I have problem with.
you ever see this?
Yes, I've seen that before.
That's the equation of a what?
Midpoint.
No, straight line. That's the equation.
Yes, straight.
And so
Yes.
you see this equation over here. And over here, if I graph them, since both of them are straight lines, is it going to look like that?
Oh.
And I want you to observe something. Where are they intersecting?
At 10 and 15. What?
I'm telling you. And once we get that,
10 and 15. What? Whoa.
right. And so the 15, when you're writing points, right? What goes first, the x or the y value?
The x.
So the graphical solution, if I were to plot these two graphs, they would intersect at 15, 10. So x would be equal to?
The 15.
And y would be equal to?
10. What?
Yeah.
That's crazy.
I'm telling you, maths is very cool. Honestly, like I really love maths. I don't know why people don't love maths, but like it's genuinely cool. And let me explain why.
I don't like maths, but since you explaining it makes it cool.
Thank you. That's why I was calling Mathvybes.
Yeah.
By making the maths a vibe. So
Yeah.
why is that the solution? You're probably wondering, like, why? Why are we looking for a point of intersection?
Yeah.
Well, any point, let me explain something. Any point on this line, enter will give my
Yeah.
x y value.
Mm-hmm.
If a point is on a line, should it satisfy the equation of the line?
Yes.
Yeah, because it's on the line, right? It's on the line.
Yes.
Okay. If I read off this point, it will satisfy this equation, yes or no?
Yes, it will.
It will. Let me try that, right? Let me take our point. Let me take this and read off that point from it as well.
So 10 and 20.
So x is 10 and y is 20. So if I plug it into this, it's supposed to satisfy it, right? Let's see.
Yeah.
2 by 10 plus 20. 2 by 10 is 20. 20 plus 20 is 40. Does it satisfy it?
Yes.
Do you think that same point will satisfy this line?
No.
No, because that point not on the line, right? It's not on this line.
Yeah.
You understand everything I'm saying so far?
Yes.
But if we look at this point, doesn't both of them pass through this point?
Yes.
Yeah, both of them passing through that point, and that is why that's the answer. Because if both of these lines passing through this point, then enter that point,
Mm-hmm.
it would lie on both lines.
Yeah.
Yeah. And so if you plug x is equal to 15 and y is equal to 10 in both of these equations, it will satisfy it. And we did that. In the previous examples, we did that and we saw that it worked out. Because watch, 2 by 15 plus 10, that is 30 plus 10, which is equal to 40, right?
Yeah.
And over here, this going to be 15 plus 2 by 10. That'll be 15 plus 20, which is 35. Yeah. Are you mind blown?
Yes. Yes.
So,
My mind is blown right now.
so when you're doing coordinate geometry, hopefully a teacher will do it. Hopefully. But this is a graphical way to solve it. So any system of linear equations could be graphed
Yeah.
out and solved like this. And I think you understand why we call it linear now. Because linear kind of sounds like line, doesn't it?
Yes.
And so both of these are equations for line.
Well, I'm gonna rank the methods on how to find these. So the graphical one is number one, then elimination and then substitution.
You see, sometimes CXC, they would bring the graph and they would tell you read off the solution from the graph. That's very easy.
Yeah, because like I didn't even know that it could use the graph. And in the finals, we can get graph paper, so I can even just use the graphs to solve them.
Yes, but you would need to generate points to do the graph. Um, I'm not sure if I would do more sessions like this. We will see. But like, if you're genuinely interested in the way others teach, you could message me and I could add it to the class because it sounds like you're going into Form 4 or like you're going into Form 5.
I'm going into Form 5.
No shocks. Well,
Yeah.
I still think you would benefit from the Form 4 classes. I still think you might benefit from that because, like, you see how others explain everything, like,
Yeah.
tell in detail.
Yeah.
I still think you might benefit from it. But
Yeah, I think I would do.
that's a decision you want to make with your parents, something. But once I have time, I will help everybody in the Caribbean do better in maths. Yeah,
Yeah, my parents are good. My mom was just watching me, smiling, hearing you explain it to me and watching me understanding.
that real nice to hear, man. You
Yeah.
you understand it. Right? Maths don't have to be
Um,
maths don't have to be boring, that's all. Don't have to be boring.
because my biggest three subjects that I have problems with are math, chemistry, and accounts. Well, not really accounts though, because I was top of my class for accounts. It's just that I got a new teacher, and the teacher wasn't really meshing with my style of learning, so I kind of plummeted. Yeah.
Oh,
But
but
as I was saying, my mom seeing me making the effort to try and understand math is making her happy, you know?
yeah. And you seem like you understand it, right? Don't worry. When we
Yeah,
finish,
I understand.
we're going to look at, we're going to do a bunch of questions to just make sure you could retain everything, right?
All right.
So, but here what? Unless you have a graph paper and you know how to, like, I wouldn't lie, this is easy to do, but you need to come up with a scale, you need to generate points. It's a whole process. I could show you, like,
Oh,
if
so it's a bit longer.
you could do it on a graph, eh? You could do it on a graph, and you would need to generate at least 2 points. So you see,
Mm.
you I don't want to stray away too much, but you know about functions.
No.
All of those are examples of functions. A surprise
Oh,
function
yeah.
was the first thing you learned. Like functions is a very important thing. And so what I see in here is that you could pick a value for x, like let me just say x is 1, you could plug it in into this and get a y value. So you understand that if you put x is 1, you could say 2 by
Yeah.
1, y is equal to 40, and you could solve for y would be equal to 38, but you could turn across the two.
Yeah.
And so you could use that to generate some points. Now, if you want to plot a line, and the least amount of points you need to plot a line is 2 points.
Yeah.
Yeah, so once you come up with a scale, and if they tell you to solve it graphically, you're going to come up with a scale, you're going to generate 2 points, you're going to draw the lines, and you're going to read off the pointer intersection. That's it. But this class was mainly for elimination and substitution. So maybe as I
Yeah.
later, I'll show you the graphical method more in depth. But I just have to show you how it is worked too, because it's cool.
Yeah.
So let's move on to example 3. Let me do the elimination method first, because I think is the easier method, of course. And so we want to cancel off x or y.
Let's cancel Y.
Y. Okay, that's going to be a little tough. So we have +2 and we have -3. Now
Yeah.
we want, here what, I will help you with this one, and then I will show you another way you can do it. So if I have +2,
Mm-hmm.
if I have +6 and I have -6, should I subtract those two from each other or should I add them together?
You should add.
Yeah, because if I add +6 and I add that to -6, wouldn't they cancel off?
Yeah.
Right. So when you're faced with a situation like this, you should find the LCM. You should find the lowest common multiple of what you're trying to cancel off. So you're trying to cancel off y. So where's the
Yeah.
LCM between 2 and 3?
1.
No, 6.
Oh, LCM.
Yeah. So LCM means lowest common multiple. So some multiples are 2 would be 2 by 1 is 2, 2 by 2 is 4, 2 by 3 is 6. 3 by 1 is
Yeah.
3, 3 by 2 is 6, 3 by 3 is 9. That's what I mean. And so was the
Yeah.
lowest value that they have in common? That would be 6. Lowest value they have.
Yeah.
So you understand that.
Highest, highest common multiple is the opposite, right?
Say that again?
Highest common multiple would be the opposite, right?
Well, yeah. The highest common multiple, it don't really have a limit to that. Like you could go on for infinity. That really makes sense.
Oh,
You mainly just look at the lowest common multiple. Understand what I mean, right? If we're looking at the
yeah.
lowest multiple, let me just show you how to generate multiples, right? Do you know what a multiple is?
Yes.
So like a multiple is any number that I could multiply 2 by. So I can say 2 by 1 is 2. I can say 2 by 2 is 4. I can say
2 by 2 is 6.
6, then 8, then 10, then 12, etc., etc. And I could go on for
Yeah.
infinity. And I could go on for infinity. Just keep counting. I could,
So,
right?
yeah.
I could keep going forever. But 3 now, 3 would be 3, 6, 9, 12, 15.
15,
I could go on
18.
and understand if I keep going down forever, N would always have a higher multiple. Like if I were to extend this N later down the line, it would have something that could also be in common with 3.
Yeah.
Because you see in that 6 is the lowest common multiple, right?
Yeah.
Then you see in 12. And if I were to
That's
cut
the highest.
and eventually I would get 24 here and I would get 24 here because 12 by 2 is 24 and 8 by 3 is 24.
Yeah.
And then 24 is our common multiple. Yeah, but like
Mm-hmm.
it could keep going down. And so highest common factor really makes sense. We could just use the lowest common multiple.
Yeah.
Right. I hope I just now didn't say factor, right? This is multiple. We're looking at multiples here. We just multiply. So the lowest common multiple between 2 and 3 is 6. So what would I have to do with this equation to make this 6?
Multiply by 3.
If I multiply that by 3, that's going to turn to what? What is that going to turn to?
So it's gonna be 9x plus 6y equals what's that? 6 plus 3 plus 1. So that's gonna be
48.
equal to 48. Yes.
I'm a bit, I'm mathy magician. And
Yeah.
maths on lockdown. You'll get like that too, don't worry. And so, what should I do with this if I want to turn this -3 to -6?
You're gonna multiply by 2.
Right. And so that's going to turn to what? Tell me what's going to turn to.
10x minus 6y equals 2.
Right. Lovely. So, can we now work with these two equations?
Yes.
So if I want to cancel off the y, what should I do with both of the equations? Add them or minus them?
We're gonna add them.
Right, because if I add 6 to -6, it will cancel off, right?
Yeah.
I trust in you. I trust in you understand.
Yeah.
And so then we have 9x plus 10x. What is 9x plus 10x?
That's 19x.
Right? What is 6y minus 6y?
Nothing.
What is 48 plus 2?
That's 50.
Let me just check something. Yeah. This was the one that wouldn't give you nice answers. And so 19x, these are different color. Let me just use red. Yeah, so if we have 19x is equal to 50, how would I find for x now?
You're going to divide by 19.
Right. And so I will divide both sides by 19. And so x will be equal to 50. I can't really simplify that, so I'll leave it as 50 over 19. That's my answer.
Yeah.
Right. Now, which equation you want to use to find the y? You could use any one of the equations. You could use this, or this. I recommend using the original ones.
Let's use the second one.
Right. So bear with me, right? It might get a little complicated. And so anywhere I see x, I'm going to replace x with what?
50 divided by 19.
Right. So using...
That's 2.6, by the way.
Yeah, but we're going to leave it as a fraction. We're going to leave it as a fraction. Right? Use an equation 2. Find for y. And so that's going to be 5 by 50 all over 19 minus 3y is equal to 1. And so, and I could expand this out, and 5 by 50, that'll be 250. So this is the same thing as 250 over 19. Yes or no?
Yes.
And so I want to find for y, so I should move across that 250 over 19. And
So,
if I know the fractions looking at
that's going to be. So is that going to be minus?
minus 3y is equal to
1 minus 250 over 19.
Yeah, that's correct. Good job. I'm gonna blow your mind here again, right?
All right.
You can find LCM here.
Oh,
No, like and when you have different denominators, you could always just find LCM to minus them or add them.
yeah.
Yeah, like one is the same thing as 1/1, so the LCM will be 19, etc., etc. But I'm not going to show you that. I want to do that. I want to show you something else. If I want to add or subtract fractions, the denominator had to be the same, right? Yes or no?
Yes.
And so where's another way I could write 1? Let's see if you get let me see how bad it is. Another way I can write
1
1.
over 1.
Yeah,
1 over 1.
right? But if I have a denominator 19, think deeper. Where's another way I can write 1? And I would include
1
9.
over 19.
No, 1/19 is not the same thing as 1.
Same thing as 1. Is it 19?
No, 19. Wait, tell them that 19 is the same as 1. Hey,
Another
take your time.
could write 1.
This is gonna be on YouTube. People might think you're crazy. I'm gonna ask that question. Is 5/5 same thing as 1?
Yeah.
So if I want to include 19,
Oh, 19 over 19.
yes, 19/19.
I was thinking YouTube, I'm not crazy.
Right? And so since I have the same denominator, I could just say 19 minus 250 over 19.
Yeah.
Obviously, you can just work it in a calculator, right? You have a Sharp or a Casio.
Uh, it's one I bought at my school. It doesn't really have a brand.
Oh, well, I recommend getting this calculator. This is the best calculator you could get. This is the best one.
Yeah, I'm gonna get a Casio.
Yeah, you gotta get a Casio. Casio is life. It's the best. Because watch this, right? On most calculators, you can't put in fractions, but on a Casio, you could. Watch. So I could put 19 over 19 if I wanted,
Yeah.
right? Minus, I could put it exactly how I've seen it. And I'll get the answer there. Minus 231 over 19. Right?
Mhm.
Right? So 19 minus 250, it said that was minus 231 all over 19. And now I understand it looking real complicated. I understand. Honestly, I understand, right?
Yeah.
But it's not that hard. Understand that it's just the same process. It's just looking complicated because it's a fraction. But it's not complicated. It's really not complicated. So stay with me. You understand how I reach this point?
Yeah.
Okay. And so if I want to find for y, it's the same process. I would have to do what on both sides?
Yeah. You have to divide.
Right. Now, I feel like this might confuse you. Like if I do this, like that might look a little confusing, and
Yeah, because it's like a triple fraction.
yeah, I understand. Like it's looking kind of confusing, honestly. So what you could do is I would recommend, like instead of doing that, I would recommend doing this. Just say divided by minus 3.
Okay.
And so we know the minus 3 and the minus 3 will cancel off on the left hand side. So that's gonna turn to y, right? And on the right hand side, you could plug this into your calculator. Now, depending on the calculator you have, can your calculator put in fractions like this? Yes or no?
Yes.
Yeah. So I'm picture that. That's all like a good calculator.
Yeah, it's a decent one.
Yeah, so what you want to do is you're gonna put minus 231 all over 19, and you're just gonna put divided by 3. Or minus 3, I mean. And you should get 77 over 19.
All right.
I'm coming back in like 2 minutes.
All right.
All right, did you get the 77 over 19?
Yes.
Right? Now you're probably saying, well, shucks, but I kinda screwed, yes. Because like the other examples was easy, right? It was easy to see if it was correct. Because I mean it was nice numbers, right? You gotta plug it in and gotta see. But
Yeah.
this one looking a little tricky because like the answers again kinda annoying. So let me
So what? Just just work it out. So like find out what's 19 divided by 6. What 77 divided by 19. Get the decimal.
well I wouldn't recommend that because you wouldn't get the exact answer. This is what I would recommend. So pick a equation. Which equation you want to test to see if it's satisfying? One or two?
1.
Okay, so I'm gonna put 3 by, and what did we get x to be? X was 50 over 19,
Yes.
right? So I put it over here. So 3 by x, which is 50 over 19, right? Plus 2 by y, and y is 77 over 19. And what that's supposed to be equal to? When I click that equal sign, what is supposed to be equal to?
So you got to be 16.
You think you're gonna be equal to 16?
Yes.
Oh, you see. Badness. Watch that.
What?
Yeah. Right?
That's crazy.
Yeah. Let me try the other one. Right? And that's gonna be 5. X is 50 over 19 minus 3 by 77. And when we press an equal sign, what's it supposed to be?
Supposed to be 16.
No, it's supposed to be equal to 1. This is the second equation now.
Oh, 1. Oh yeah, 1, yeah.
Bam.
What?
Yeah.
That's crazy.
Right? So we definitely got the correct answer, right? We got the correct answer. So we're good. We're good.
Yeah.
Let me do
That's crazy.
pick an equation to make equation 3 from.
Um, can you use equation 1? No, 2.
Okay. We want to make the subject.
Let's go for Y.
Yeah, choose any tough ones. That's good. That's good. So we have 5x minus 3y is equal to 1. You want to make y the subject, so you should probably move across the 5x.
Yeah.
So tell me what to write.
Negative 3y is equal to 1 minus 5x.
Right. And if I want to find for y, I would divide both sides by minus 3, right?
Yeah.
And so y would be equal to 1 minus 5x all over minus 2. Things are getting a little scary, but it's easy. So since we use equation 2, well, we had to plug equation 3 into.
We're gonna plug it into equation 1.
Right. So I'm going to say 3, and anyway I see y, I'm going to write 1 minus 5x over minus 3. Yes or no?
Yes.
Because y is the same thing as that. Now I might lose it here, right? Stay with me. This is this is the trickiest example. It don't get trickier than this at other level. In maths, it don't get harder than this.
All right.
So I'm gonna write back to 3x and I'm gonna say plus 2. Do I need to put brackets?
Yes.
Yeah, I need to put brackets. I really need to.
Because it's a binomial.
Yeah, that's a binomial. Right? And that'll be equal to
1. No,
right.
16.
Oh yeah, 16. What? Yeah, I get catch. Because 60, because we use equation 2 to make equation 3, so we use an equation 1. Right.
Yes.
So do we like working with fractions?
No.
What should fly by on like everywhere? Everywhere. What's in the denominator?
The negative 3.
Negative 3. So I should probably multiply everything by minus 3. What is 3x by minus 3?
3x by minus 3. That is
And
that's 2.
now 3 by negative 3 is negative 9. So we negative 9x.
Yes.
Right? You see this whole thing over here? If we
Yeah.
multiply that whole thing by minus 3, what do you think I should write? You tell me. I'll be plus what?
Plus the 9.
9. Where you get 9 from?
The 2.
Plus 2.
Hold on.
Yeah. Maybe if I
Right.
put over here, you will see it better. Watch. And we multiplying that by minus 3. What's going to happen?
So 9.
Wait, wait. I'm confused where you getting 9 from. Take your time, right? So you're seeing minus 3 over here, and you see minus 3 on top. So that's going to cancel off. And so,
Oh no, what I was doing? I was multiplying the 3 by the 1 up top.
nah, watch. Because you had negative 3 in the bottom, it would,
Yeah, so they cancel.
so where's it going to begin with? 2 by,
1 minus 5x.
right, and that's in brackets.
Yeah.
And they're going to multiply the right-hand side by minus 3. 16 by minus 3 is minus 48. So now we have to expand the brackets. And so everything we're going to multiply by positive 2.
Yeah.
So after this, you should be very good in simultaneous equations for sure. Like, I think it should be okay. If not amazing, okay. All right. And then 2 by 1, that's 2. 2 by minus 5x is what?
2 by minus 5x, that would be 2. That would be 10x.
Negative 10x, because a positive by a negative is a negative.
Yes.
Right? And well, let me group together the like terms. We have minus 9x and we have minus 10x.
Yeah.
Don't tell me a negative by a negative is a positive, eh? That is only on a multiplication. Now, hear what I'm saying. Pay attention. Don't tell me a negative by a negative is a positive. That is only if you have multiplication. Are we multiplying anything over here?
No.
So imagine you take 9. Let me just say I have a partner, right? You take 9 and he go. And then you take 10 more of he go. Now the man have 19 x's. So minus 19x.
Yeah.
I have very good examples.
Yeah.
I'm not speaking from experience. Just So minus 9x minus 10x is minus 19x. You understand what I'm saying? Like if you take 9 and you take 10 more, you take 19 altogether.
Yeah.
So that's minus 19x plus 2. So I confuse you at all.
No, no.
What should I do next?
Now you're gonna get rid of the 2.
You're going to move it across.
So it's gonna be minus 2 on both sides.
So tell me what to write then. You tell me what to
Minus 19x equals minus 48 minus 2.
Yes. And you're going to get, let me get some kind of tied for space. Give me a second. Just make some space here.
So that would be equal to minus 19x equal to minus 46.
No.
Or minus 50. Oh, you're gonna add it now.
No, think about it like this, right? If you take $48 from somebody and you take
Yeah.
as a gain, how much you take from them altogether?
Oh, 50.
Yeah, you can think about it like that. If you take negative, you can think of negative as taken. So you take in 48 and you take in 2 again. So negative 50. And so
Yes.
if I want to find for x, what I had to do on both sides?
You have to divide by minus 19.
Right? And I'll get my answer, right? I'll get
Yeah.
x will be equal to what?
Minus 19.
No.
Minus 50.
So we have a negative divided by a negative. What is a negative divided by a negative?
Positive.
Right. So x is supposed to be equal to?
Positive 50 over 19.
Right. You okay with that?
Yeah.
Right. And we have x. And we got that same value over here. We just did a lot less working though. A lot less working, but yeah. We get 50 over 19. So
Yeah.
what am I going to use to find for y?
Can use
Remember,
equation 1.
you could use equation 1, but remember, what's the best equation to use when you're doing substitution? Equation.
The third one.
Yes, the third one, because the third one is telling us what y is equal to, right?
Yes.
And so y is equal to 1 minus 5x all over minus 3.
Yeah.
1 minus 5, 50 over 19.
Yeah.
So again, your the calculator you have, right? Just confirm again. You could plug in fractions like this, right? Like exactly how you're seeing it on the screen. You could do that.
Yes.
Yeah? Okay. Well, it shouldn't be hard for you then. So this is what you're gonna do. Right? So you're gonna open up the fraction and you're gonna put 1 minus 5. You're gonna press the fraction button again. Wait, no. Wait. You're gonna say 1 minus 5, then you're gonna open up a pair of brackets. You're gonna press the fraction button again. You're gonna put 50 all over 19. You're gonna close the brackets. And in the denominator, you're gonna put minus 3. Do you have that on your calculator? If not, tell me.
No, I can't do the one where you open up the other fraction.
Wait, tell me a picture of the calculator I have fast. If you could.
Oh yeah. No, I can't do it.
Oh, shucks. So you can't wait in here.
Oh yeah, I can do it. I can do it. My bad. I didn't press the bracket.
Oh, okay.
So let me do that real quick.
So Demarley, you think that Lines is the only kind of graph it have?
No.
No, it have circles, it have curves, it have all kind of things.
Yeah, I know. Because in chemistry, you have the heating curve and all that.
Yeah, yeah. Bunch of things. Let me ask that question. You think if you have two parallel lines, they will have a solution?
Yes.
Think about what you just now say. If I have two parallel lines,
Oh, no. No.
will remember to find the solution you're looking for where it intersecting. If you have two parallel lines, will they ever intersect?
No.
No. So if two lines have the same gradient, you'll never get a solution because they'll never intersect because they're parallel.
Yes.
Right? When you work it out, you're supposed to get 77 over 19, right?
Yeah.
And that was the same answer we got when we did the other method. So everything is consistent. No, no confusion. Everything made sense. So
Yeah.
this is the hardest question we did by far. And it will not come harder than this. Yeah.
Well, you make it look easy. So,
Thanks. Thanks. But this
uh,
is,
if my teacher tried to explain this to me, I'd be scratching my head the entire time.
I feel like you're begging up too much, and I feel like you're begging up too much. I don't know. I don't know how to take compliments now. I don't know. But I'm glad you understand it. And this will be the hardest example. But we're gonna go a step further. Do you know how to factorize quadratic something?
What? Nope. Nope.
Oh.
Big nope.
Well, I'm still gonna show you because I feel like at some point you might have to learn it and you will learn about quadratics. So we're gonna do it anyways. But
Yeah.
this is more so for the advanced students. It's still gonna benefit, but it's more for the additional mathematics students that are watching this video. So at your level, and when you're doing maths, this is the hardest example you'll get. And watch, if I graph, if I do the graph,
Yeah.
look at the point of intersection. Watch. And that's the solution we got.
Oh.
Yeah. We got x to be 50 over 19 and y to be 77 over 19. That's where you got over here.
Yeah.
Yeah. So we're gonna arm things up a little bit. This is like danger zone. Things gonna get dangerous now.
I don't like the sound of that one.
Because watch. Okay, this is a linear equation, but look at this. What is this? What is that?
That's a non-linear.
No, that's not linear. Remember what I tell you? It's linear if it don't have a power. Over here,
Yeah.
over here it's to the power 2, which means that this is not linear. And anytime you have linear and non-linear case, you can't use elimination. You have to use substitution. You have to. There's no,
Oh.
you have to. All right, so I'm gonna show it anyways. So we're gonna call this equation. You know how the badnesses go by now, right? We're gonna call one equation one. We're gonna call the other one equation two. You
Yeah.
know, um, I'm gonna help you here because it's very easy to get lost. Now, which one looking easier to work with? Equation one or equation two?
Equation one.
Right. So we're gonna use equation one to make equation three because it's simpler. So let me ask that question, Demarley. This graph is going to be a line, right? That's a line.
Yeah.
Not doing hard maths. So never hear about this, but this is not the equation of a line. This is the equation of a circle. So if I graph that, is actually a circle gonna pop up. And this is our line.
Okay.
Now, if you have a
Yeah.
line, let me understand what we're in. If you have a line and a circle, remind me, if you're trying to solve it graphically, you're looking for the points of
X and Y.
intersection. That's all I wanted to hear. You're looking to see where the graphs cut each other. Intersection.
Yeah. Yeah.
So in this question, if I have a line and a circle, what is the most amount of solutions you think I could have? We're looking for the
2.
2. And what is the least amount of intersections I could have?
1.
Right. So let me go.
Also, that's where the power comes in.
Yeah. Watch. Because when I do the graph, this is what's going to happen. Right? And you can see that there are 2 points. You're going to get 2 answers. But that's really more for math students. So we're going to make the subject X or Y. X or Y.
Let me X the subject.
X the subject. Wait, give me a second. Demarley, you seem like a focused fella and thing. You be focusing on work and thing. You're a studious person.
Yeah.
I respect that.
Because I genuinely want to like try and understand it, because for most of my life I've been saying that I hate math, but now I genuinely just want to stop hating math and try to get it. So yeah.
Because it's interesting when you understand what going on. It's actually interesting when you understand what going on.
It's giving me that math vibe. See what I did there?
See where you do that. Yeah. Don't mind that person. I just not join. That's my girlfriend. She just had nothing better to do. So she just come to chill. Right? But
no problem.
I like the way you do that. The math vibes. I like that.
Yeah.
Put the pieces together. So you want to make X or Y the subject? X or Y?
You want to make X the subject.
Right. And so you would say X plus Y is equal to 7. And if we make an X the subject, what we should move across? Tell me, if we want to make X the subject, what should move across?
Yeah. We should move across Y.
Right. And so X is equal to?
7 minus Y.
And that is equation 3. That was real simple, right?
Very simple.
Don't let it confuse you. Don't let it tie up. It's not going to be so simple, right? And so anywhere I see X now, I'm going to write what?
7 minus Y.
Right. Plug that into equation 2, because we use equation 1 to make equation 3.
Yeah.
You know what squared means? Like if I write 5 squared, do you know what that means?
Yes, it means like the number times itself.
Right. So that will be 5 by 5. So keep that concept in mind. So we're going to write X plus 7 minus Y squared plus Y squared was equal to 25. So you see that you never did quadratics as yet, but this is a kind of introduction to it. So if you are telling me 5 squared is 5 by 5, wouldn't 7 Y squared be 7 minus Y by? Try to figure it out.
7 minus Y.
Yeah.
So it would be 14. No, not 14. What's 7?
Gotta be real careful when you're expanding this, eh? So to expand this, you're gonna
be 49 minus Y.
The minus 7.
2Y.
No, you gotta be real careful about this. Like I said, I introduced it to some more advanced stuff. So you're gonna take this 7 and you're gonna multiply by everything in the second bracket. And so tell me, what is 7 by 7?
49.
Right, then what is 7 by minus Y?
7Y.
No. Remember,
minus 7.
Minus 7Y, right? Positive by negative is a negative.
Yes.
We finish with this. We finish multiply the 7 by the terms in the second bracket. We're going to minus Y now. What is minus y by 7?
That's 6y.
No, we're multiplying minus y by 7. If I asked you what is y by 7, make a tell me.
That's 7y.
So what do you think minus y by 7 will be?
Minus 7y.
Right, exactly. So it's going to be minus 7y. And what is minus y by minus y?
Nothing.
Nah,
Just minus y.
nah. If I ask you what is y by y, what do you tell me?
Minus 2y.
Nah, nah, nah. If I have 5 by 5 and that is 25,
Yeah.
wouldn't that also mean 5 squared?
Yeah.
So what do you think y by y is? 5 by,
Y squared.
yes.
So it's minus y squared.
No.
Just y squared.
Yes.
No, it's the minus sign that's confusing me.
But you see, it's a negative by a negative, right?
Yeah.
So that will be plus y squared. Because it's a negative by a negative is a plus. Right.
Oh.
So I'm gonna lose here. I understand that, but when you learn quadratics, maybe you could come back to the video and try to understand what I did. But
Yeah.
we're going to group together the like terms. So we have y squareds. We have two y squareds. We have
Yeah.
1y, negative 7y, and we have a number. So if I have y squared and y squared, wouldn't that be 2y squared?
Yeah.
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 Right?
So 2y squared.
I understand how I get it 2y squared.
Yeah.
And okay, minus 7y minus 7y. Remember what I tell you? If you take 7 and you take 7 again, how much you take altogether? Like if you take $7 and then you take $7 again, how much money you take altogether?
14.
So that'll be negative.
14. Y.
Right? And we're gonna put back the plus 49. We didn't do anything with the 49. I'm just writing it over there now.
Yeah.
And that's equal to 25. Now I'm going to take that 25 and I'm going to move it across. Again, this is unfamiliar territory, but I essentially want to put it in the form of a quadratic. The form of a quadratic is ax squared plus bx plus c is equal to 0. Trust me, when you're doing quadratic cycle, it makes sense. But I wanna bring across everything so that it would be equal to 0. And on the side, if I take away the 25 on the right hand side, it would just be 0. So I'm gonna end up with 2y squared minus 14y plus 49 minus 25 equal to 0. So that's going to be 2y squared minus 14y. And what is 49 minus 25?
That would give you 24.
Right. Now, I want to simplify this. If you notice, everything there are factors of 2. Meaning that if I divide short by 2, I can simplify this thing because and 2 is divisible by 2. Like 2 could go into 2, right?
Yeah.
14 could go into 2 how much times?
7.
I say that back. I say that like a Guyanese.
Yeah, I just realized because you said how much 14 can go into 2.
I think Guyanese for a second there. I supposed to say how much times could go into 14, right?
So that's 7.
How much times 2 could go into 24?
12.
Right, so I'm going to divide throughout by 2 to simplify things. And so that's going to be y squared minus 7y. You're probably wondering why is still negative? Well, it was a negative divided by a positive, so get back negative 7y, right? 24 divided by 2 is 12. So this is the situation I have. Right. Now, to solve this, again, it will make sense. We're just soak it in for now. It will make sense when you're doing quadratics. If I want to factorize this thing, and I'm factorizing to solve it.
Yeah.
To get y squared, doesn't that mean y by y?
Yeah.
And I'm looking at the last here how this going, right? I'm looking at the last number. The last number is 12.
Yes.
How could I multiply to get 12? Give my
What?
example. How I can multiply to get 12?
6 by 2.
Okay, that wouldn't work. I want whatever you choose here, it had to give me a negative 7 back. And so, what are some numbers you can multiply to get 12 but add to give you 7?
4 and 3.
4 and 3. But I want to get negative 7, right? So, instead of saying 4 and 3, I could say negative 4 by negative 3.
And negative 3. Yeah.
Marks that question, and negative 4 by negative 3 is still positive 12?
Yeah.
What is negative 4 plus minus 3?
Negative 7.
Right, so I'm going to say y minus 4, y minus 3 is equal to 0. And I want you to understand why this is making sense. I'm going to get two values for y. Why does that make sense? Well, you have a circle and a line. And a line could cut the circle at 2 points.
Yeah.
We had to get two solutions. And so, here's how I think about it. If y is 4, and 4 minus 4 is 0, and 0 by anything is 0.
Oh.
And so y would be equal to 4. And so what other value for y would make this equal to 0?
Repeat.
So what, you see how I say y is 4? And that would make this be 0? Because
Yeah.
4 minus 4 is
0.
and 0 by anything is
0.
yeah. So what do you think is our other answer for y? Y could also be equal to what?
0.
Nah. I want to
I can also be equal to
look at how I do it again, right? So I'm saying and anything by 0 is 0.
yeah.
So if y is 4, what is whole bracket gonna become?
That bracket is gonna be 0.
Right. So what would y have to be to make this bracket 0? What minus
3.
3, right?
Yeah.
And so you understand that if y is 4, you're gonna get 4 minus what is whole bracket gonna be 0, and 0, we don't really care where you get over here because 0 by anything is
0.
right. And when y is 3, this bracket going to into
0.
0 by anything is
0.
right. So again, y is equal to 4 and y is equal to 3.
Yeah.
Cool. And to find for x, I'm gonna use equation 3, right?
Yeah.
And so equation 3 was x is equal to 7 minus y. X is equal to 7 minus y. So I'm gonna get two answers, right? I'm gonna get two answers. So my first answer is gonna be when y is equal to 4. So when y is equal to 4. So that's gonna be x is equal to 7 minus 4. Yes or no? You confused by that part?
Huh?
Are you confused by that part?
No.
So x is 3. So my answer is going to be 3, 4. So when x is 3, y is 4. So help me now. When y is 3, how would I find x? X would be equal to what?
X would be equal to 4. Not to 3. Sorry.
Yeah.
Yeah.
So x would be equal to?
It's 4.
Yeah. 7 minus 3, 4. And so that's going to be 4, 3. Because x first, then y.
Yeah.
And so I want you to look at this and watch. 3, 4, 4, 3.
Whoa. Yo.
Yeah, so we figure out the whole question without even seeing what it looked like,
Yo.
which is very cool.
That's cool.
All right. So these are your two answers, and it would work out, right? And if you didn't trust me, you could have plugged it into either one of the equations, and it's supposed to work out. So which equation you want to test with? Equation 1 or equation 2?
Uh, let's test it with equation 2 since that one is a little bit trickier.
Okay, so we have x squared plus y squared is equal to 25. And so let we use this one here. So when x is equal to 3 and
Give
y,
me a minute.
okay. Also, you mightn't have any idea who this fella is, but by chance are you Tavon?
Huh?
It's something like one of my partner named Tavon now. Like it's crazy how similar it's on. Yeah. But yeah,
Well, I guess it's
well,
probably a sign from the universe that you're supposed to be helping me.
I guess so. Wait, give me a second. Yeah, because I just help my friend with maths all the time. And he just song like I don't even lying, like he had the exact same voice as him. Like it's crazy. Like you
I
could
guess it's a sign.
you sure he's not the one?
Maybe.
I doubt. But
I mean, I doubt it because since I'm from Jamaica, and I guess I doubt Kevin is from that place.
no, my friend is from St. Vincent and the Grenadines. But the accent is extremely similar. Like this is remarkable. I was always telling him he sound like he from Jamaica.
That's crazy.
And then he just say that same thing too. He's be like, "That's crazy, bro." And I'll be, yeah, yeah, that
Well, I guess I have something to admit. Since since the call, I've been trying to mimic your accent because I thought you would understand my accent.
I I don't have a problem understanding Jamaican accents. It is, but you could tell I'm Trinidadian. Can you tell I'm
Yeah,
Trinidadian?
I can tell. That's why it's kind of embarrassing because I'm like, why am I trying to do this? Like, and I'm not doing it anymore. Like at the start of the session, like for the first 5 minutes, I was like, oh no, this guy's Trinidadian. I need to mimic his accent so he understands what I'm saying. But then I realized we're from the Caribbean. We understand each other. Why am I doing this?
Exactly. Like all of we just talk the same way. You know what I mean? Like
Yes, it's just that like Trinidadians they just have a slight difference in the accent. Like some of the words they say it as bit differently.
a bit, but I wouldn't say it's that far off. I wouldn't say it's, but uh, when I was doing so I had a 17-hour marathon, right? And people from all over the Caribbean come. And like, not gonna lie, some of these students from Jamaica had a hard time understanding what they say. I'll be honest, I was having a hard time. But you're fine. I can understand everything you're saying clearly.
Yeah, cause I don't, cause you see in Jamaica you have, it might sound weird, but there's different levels of how of the power. Cause you see people from other parishes, their power might be a little bit more dense than people in Kingston, which is where I'm from. Kingston, it's the closest you'll get to standard English because our patois we still say some English words regularly and not in patois. But you see, in other parishes now, their patois is a bit deeper. They use like the real one, like the real patois, which is what everyone knows.
Real bad man.
Real bad man.
Anyway, let me wrap up. So we have
Yeah,
the last example, right? And then we're gonna speed through these questions. So
yeah,
this is the last example, and like this would cover everything for simultaneous equations, like everything. So like
yeah.
we do everything for simultaneous equations. So the last one looks a bit deceptive because you might think both of them are linear because you're not seeing a power here, right?
Well, no, I'm not seeing one, but I didn't think it was linear though because the second equation looks It looks
It looks
weird, so I'm assuming that's a nonlinear.
it's actually something called a hyperbola.
A what?
I know. Like when you're doing quadratics, you're gonna learn about parabolas. Well, this graph is a hyperbola. Hyper
That sounds like the word in English that's what's it? Hyperbole. That's when like exaggerating.
Yeah, it does sound like a hyperbole, but it's hyperbola. Yeah.
Wow.
This is what it looks like. This is what it looks like. This is what a hyperbola looks like. And,
I've seen something like that somewhere before, but I can't remember where.
and well, obviously the other one is a line, right? And so if you have a hyperbola, I hope I'm saying it correct. Big maths teacher. I should say it correct, right? But oh well. I think I'm saying it good enough. Honestly,
It doesn't really matter how you say it. As long as I have the spelling down, I'm great.
right. And so you understand that just by looking at it, there are 2 points of intersections. So whatever we do, we're supposed to get two answers, right?
Yeah.
So let we proceed. What do you want to make the subject? Which one you want to use to make equation three? Which one?
I'm just gonna go with the first one
Right.
because the second one looks too confusing.
You don't want to do that. You'll tire up yourself because then you're gonna multiply throughout by a variable. Like if let me just say you make y the subject, that will be 6 over x. And so that will be x minus 6 over x is equal to 1. I don't feel like it's that hard to understand. I mean, like, and you understand what's happening? If I want to make
Yeah.
a subject, I would just divide both sides by x. So I would just have y.
Yeah.
And
Yeah, that's the part. Like I like when I looked at it immediately, I knew that was what was gonna happen. But like I was like, no, there's something else that's gonna trick me, so I don't want to do it.
yeah, I'll trust this you sense, but nah. And over here now, you want to get rid of the fraction. So I should multiply by on both sides to get rid of the fraction.
The X.
Right. And x by x is x squared. The x will cancel off here, so just minus 6. And it'll just be 1 by x is x. So yeah,
Yeah.
I don't think it's anything you can't figure out. But
No, I'm understanding it.
but the method I'm going to show you here is simpler. So we want to make the subject x or y.
Let's make Y the subject. No, not Y. X. Let's make X the subject.
That'll be easier. That'll be easier, right? Use an equation 1.
Yeah.
Make equation 3. So I have x minus y is equal to 1. And I want to find for x, so I'm going to move across what?
Yeah.
What am I going to move across?
You're gonna move across the Y.
Y or minus y? Say the full thing.
Minus Y.
Right. And if I move across the minus y, that's going to turn to what?
That's gonna be equal to 1 minus Y.
No, no. If you move across something,
Oh, 1 plus Y.
right. Alternatively, you could think about it like this. If you want to get rid of minus y, wouldn't you have to add y on both sides?
Yes. The reason why I said that was because I've gotten so used to the badness where we were like just every time we put it over, it's always minus. I didn't remember that when it's every time you go over the equal sign, you must change the sign that's already there.
Yeah. So it's a good thing we do this question. It's a good thing, right?
Yeah.
X is equal to 1 plus y, and that is going to give me equation 3. And so anywhere I see x in equation 2, I'm going to plug that in, right? So plug equation 3 into 2. And so what am I going to write? Don't forget the brackets, eh? So tell me.
So we're gonna write 1 bracket. So bracket 1 plus Y, close bracket, E minus Y, equal 1.
Wait, hold up. Wait,
Wait, hold up. Yes, hold up for real.
yes.
It's gonna be y, then y equals 6.
So yeah, I agree that this is correct, right?
Yes.
So this whole thing gonna be x. Yeah, we know that.
Yeah.
And so xy is equal to 6, right?
Yeah.
Now, we have something on the outside, so we have to expand it. So that y is going to multiply by everything on the inside. So what is y
Yeah.
by
That's just y.
what is y by y? You should know by now from like the example I gave you with x by x and 5 by 5. Y by y is,
So that's y squared.
right? And I'm going to move across 6 one time. So if I move it across, it's going to turn to.
Uh, to 6.
Anytime you move across something, what happens to the side? Don't forget that.
Yeah.
That
So that's gonna be equal to minus.
6. Right.
Yeah.
Gonna take that 6 and move it across one time. Actually, I should probably take. I'm gonna jump the gun. I'll take my time, and then I'm gonna move across the 6 because I want to put it in the form of a quadratic. You never did quadratics before, but I want it to be in
Yeah.
the x squared plus bx plus c is equal to 0. So I need it to be equal to 0, and to do that, everything on your right hand side I have to move it across. So I'm left with nothing on the right hand side. So tell me if I confuse it here. I'm gonna write y squared plus y minus 6. How about I confuse it there? Like, were you confused by how I switch it?
Yeah. Go back over it one more time.
Max, that question. If I have 1 plus 3, could I also write that as 3 plus 1? Does it really matter?
Oh yeah.
And so if I have y plus y squared, does it really matter? And I could write y squared plus y?
No, it doesn't matter.
It doesn't matter because addition is commutative. It doesn't matter the order.
Yeah.
And can you can you see that it is in the form? So we have something squared, then we have something that's not squared, then we have a constant. So it's in the form, even though like in the form, it is in the form.
Yeah. I see it. I see it.
And so let's factorize this. And so the first question I'm going to ask you, what by what going to give you y squared?
Y by itself.
And then we're looking at the last two. Remember how does go? You're looking at the last two. And you want to figure out what two numbers could multiply to give you minus 6, but add to give you, what's a number in the middle? You're not seeing it, but that's plus what?
So
The number
I'm trying to find the two numbers that can give me minus 6 that can be added.
to give you, what is this number here?
Oh, plus y.
No. Mm-mm. What's the number? They're not seen in front, but it's actually in front.
Oh, 1.
Yeah. So 1, right? Because this means 1y. And so think to yourself, what are two numbers that could multiply to give you minus 6, but add to give you plus 1?
So I'll take it plus 1. So 0.5?
Wait, what? Nah. Think of some nice numbers. Like, wait,
No, 0.5 is 0.5 plus 0.5 can give me 1.
no.
But
We looking? Okay, think of this first. How we can multiply to get minus 6? What are two numbers you can multiply to get minus 6?
2 and 3.
Right, 2 and 3. But I will give you a positive 6. I want to get negative 6. So just remember, a negative is a positive by a negative or a positive. So
Yeah.
make some changes here.
So add the minus.
Where should I put the minus? By the 2 or the 3? Keep in mind, I want to get a positive 1.
So we're gonna put it at the 2.
Put it by the 2?
Yeah.
I agree. If you multiply minus 2 by 3, what are you going to get?
Negative 6.
Right? And if you plug minus 2 plus 3 in the calculator, minus 2 plus 3, you're going to get
That's gonna equal to 1.
right. So we're not here. We're ready. So we're just going to write the minus 2 here, and we're going to write the plus here. And so, what would y have to be to make this bracket turn to 0?
2.
Right? And what would y have to be to make this bracket turn to 0?
-3.
Right? So simple. Like you just now learn how to factorize quadratics.
Huh?
Yeah.
Yeah.
2 and y is equal to 3. So what equation am I going to use to find for x? Remind me, when we're doing substitution, what's the best equation to use to find for the other unknown?
Sorry, wait for a second. What you say now?
Yeah. When you're doing substitution, what is the best equation to use to find for the other unknown? Equation what?
To find for the the third one.
Yeah, the third one. Wait, take a second.
Yeah. Huh?
Yeah. And so we're gonna use the third one, right? So the equation was x is equal to 1 plus y. X is equal to 1 plus y. So when when y is equal to 2, when y is equal to 2, what is x gonna be?
Y is equal to 2. X is gonna be 3.
Sure, right? Pretty straightforward, I would say. 1
Yeah.
plus. So your coordinate would be 3, 2, right?
Yeah.
Right. And when y is equal to -3, x will be equal to 1 plus -3. What is 1 plus -3?
Yeah.
Come.
Huh?
Yeah, tell me, what is 1 plus -3? Wait then. Demarley?
Use up the mathematics.
I use it for something else.
Eh?
I use it for something else.
It's going to finish tomorrow.
I use it for something else.
But you have 1 gig left?
Yeah.
So 1 plus -3. 1 plus -3 is?
1 plus -3 would be 2.
-2.
-2. Why do I keep doing that? I have it I have it in my head, but I keep saying the wrong thing.
Right?
Yeah.
So understand it like this. Negative means a take. If you have 1 and you take away 3.
Yeah.
Okay, a better example would be, imagine you have $1, but something costs $3.
Yeah.
You're still gonna owe them $2.
Yes.
Yeah, so it'll be -2. So the point is gonna be -2, -3. So keep that in mind. And if you had trust issues, you could always plug it back into the equations to see if it's satisfying the equations. But these are the answers. And so pick an equation, 1 or 2. Which one you want me to test?
You can test equation 2.
Okay, equation 2 is xy is equal to 6. So x.
Yeah.
So let me do this. So x is 3, y is 2. What is 3 by 2?
6. Yeah. Yeah.
This is the vibe check. What about the other one? That's -2 by -3. What is -2 by -3?
6.
Right, so we not get. That's correct.
Yeah, man. That's how the badness go down.
Right. And if you plot the graph, you will see what? 3, 2, minus 2, minus 3. 3, 2, minus 2, minus 3. So we get true. You see in here that
It's always the graphs that just blow my mind how they actually connect.
I surprise teachers in school, though, sure. I don't know what them teachers in school be doing, but I really don't know. I'm not sure.
Some of them are just lazy.
Yeah. I'm going to open up more in school one day. And so would not be like that.
That's why I'm glad I found a TikTok class. Oh boy.
Say that again?
I said that's why I'm glad I found a TikTok because I don't know how to survive with this math teacher because she's not teaching me how I understand it.
Well, don't worry. Over the holidays, well, if you decide to join the Form 4 class,
I'm going to join. What do you mean? Of course I'm going to join.
well, I just saying, well, this wouldn't be the last time we interacted. Wouldn't be the last time. Right? So these are the questions I want you to try. So you can take a screenshot of this and we're gonna speed run the questions. Like I'm gonna do elimination, right? Because elimination is the quickest method, and we're just gonna speed through it, right?
Yeah.
Okay, so just take a screenshot of that so you can do the questions whenever you feel like. And
yeah.
Okay, cool. We're gonna move on. So the first question, what could do with them two equations if I want to cancel off something? What do you want to cancel off? X or Y?
We can cancel Y.
Okay, if you want to cancel off Y, should you add both of the equations or subtract both of the equations?
Add.
You should add it, right? So what is X plus X?
X plus X, that's 2X.
What is Y plus minus Y?
None. Nothing.
What is 10 plus 4?
14.
Now I would have minus it because X minus X is 0, but this is good. I'm glad you see it like this. And so 2x is equal to 14. So x will just divide both sides by 2 and x is equal to
7.
Bam. Which equation do you want to use to find for y?
Can use equation 1.
Right? So equation 1 is x plus y is equal to 10. What we know x is?
We know x is 7.
Right? So 7 plus y is equal to 10. I want to find for y, so I'm going to move across to 7. So y is going to be equal to
10 minus 7, which is 3.
If you want to plot the graphs yourself and see it intersect, you could use a website online called GeoGebra or Desmos. GeoGebra, or you could use Desmos. So if you want to verify if it's working out, you could plot the graphs yourself and see where it intersected. So these are the two applications I use, well, websites.
Let me screenshot that.
Right, GeoGebra and or Desmos. Right. But if you wanted to check at a glance if your answers are correct, what you could do? What could you find?
You can satisfy.
Right. So let me check out equation 1. Equation 1 says if I add x and y, it's supposed to be 10. If x is 7 and y is 3 and 7 plus 3 is 10? Yeah?
Yeah.
And the other equation says x minus y is supposed to be 4. So x is 7 minus 3 and 7 minus 3 is 4?
Yeah.
So we correct. 100% correct. Cool. Let's move on. So easy that was. That was real easy.
Yeah.
Quick movements. Right. Now over here, we want to cancel off x or y?
You can cancel out x this time.
Okay. But we have to do first. You can't just add or minus. We have to do.
We got to multiply to make the things the same.
Mm-hmm. So tell me what to do. You tell me exactly what to do.
So we get rid of x. So we got to find x first. So we got to multiply that by 3.
3? If I multiply by, you're setting it up to get rid of y, not x.
Oh, multiply by 2, sorry.
Right. If I multiply that by 2, what is it gonna turn to?
That's what the second thing. 2x plus 2y plus equals 2.
Right? So that's gonna be 2x plus 3y is equal to 18. And I'm gonna write that back. So that'll be 2x plus 2y is equal to 2. We're gonna subtract. Why not adding? Why should I subtract?
Because both 2x's are the same.
Right. So once is the same, you could minus. If they're the opposite sign, you add, right? Like in the previous question, it was
Yeah.
plus and minus, so you just add one time and cancel off. And if I wanted to cancel off x here, could I just say minus and?
Yeah.
Right. So 2x minus 2x is just I'll cancel off. 3y, what is 3y minus 2y?
That's y.
Right? What is 18 minus? Here what? A lot of students make this mistake and will put 20 here. But no, it's 18 minus 2. The same way as 3y minus 2y. So what is 18 minus 2?
That's 16.
Right? So y is 16, bam. Which equation I could use to find for x? Which one making it simpler?
The x plus 2. X plus y, sorry.
Right. So x plus y is equal to 1. And so y is equal to 16. So I'm going to say x plus 16 is equal to 1. And so if I want to find for x, I'm going to move across what?
16.
Right? And so x would be equal to 1
minus 16.
Right? So x would be equal to
negative 15.
Right. I'll look at getting it. So yeah, those are your answers. So
yeah,
y is equal to 16, x is equal to minus 15. These are your answers.
Yeah.
And if you wanted to verify it, well, that's not hard. You know how to do that.
Yeah.
So let me just use this equation. So it's saying that if I add x and y, I suppose I get 1. So x is minus 15 and y is 16. If I take away 15 from 16, what am I going to get?
Negative 1, sorry. Not negative 1.
So it puts out, right? And if I wanted to check the other equation, I would say, so that'll be 2, open bracket, x is minus 15, plus 3, y is 16. When I press equal, what's supposed to get?
18.
Madness.
Badness. Wow.
Right? So we good. 100% correct. So my advice is, at your level, I would almost definitely use elimination. It's only when you have a linear and a non-linear, I would use substitution, but I would almost always use elimination. Always.
Yeah.
Right? With this question, we want to cancel off.
Let's cancel x.
Okay, but you could have cancel off something one time though.
Oh, why?
Why should we if I want to cancel off that one time?
Because that they're basically equal.
So what should do? Add a minus.
Or we're going to minus.
No.
No, add. Sorry.
If it was the same, you'd have minus. If it was plus y, you'd have minus. But it's negative y, so we minus.
Yeah.
What's the minus? Yeah, you gotta add, right? You gotta add. Yeah. Negative y plus y. Think about it. If you have negative y and you're adding that to y, they'll cancel off because they're opposites.
Yeah.
So 4x plus 2x is
6x.
right? That cancel off here. And 5 plus 11, that's 16. So 6x is equal to 16. Divide both sides by 6. X is equal to, okay, that would be 8 all over 3. You know why I say 8 over 3?
Yeah.
Because both of them divisible by 2. Right? So that's x. What you want to use to find for y?
Let's use equation 2.
Okay, so that's going to be 2x plus y is equal to 11. And so I'm going to say 2 by 8 all over 3 plus y is equal to 11. So what is 2
Yeah.
over 3?
That's 16 over 6.
No,
Or keep the same. So 16 over 3.
right. Remember, 2 is the same thing as 2 over 1. And so 2 by 8 is
Yeah.
6. 1 by 3 is 3.
Yeah.
16 over 3 plus y is equal to 11. And so if I want to find for y, what would I have to move across?
The 16.
Right.
Okay.
So y will be equal to 11 minus 16 over 3. So let me just
Yeah.
plug the calculator one time. That would be 17 over 3. And these answers looking a bit stringent.
Yeah.
But we know how to check if it's correct, no matter how strange it's looking. So let me see if it's really the correct answer we get. So which equation do you want to verify? 1 or 2?
1.
1, okay. So that's going to be 4. X is 8 over 3. Right? Minus y. Y is 17 over 3. I want to press the equal sign. What that's supposed to be?
5.
Let's see. Bam. We
Badness.
yeah. So we good. We find the correct answer. And if you wanted to do the alternative way, I just gonna speed run this real fast. You can multiply this by 2, and so I get 4x minus y is equal to 5, and that 2x that's into 4x. 4x plus 2y is equal to 22. Yeah, that subtract. That'll be minus 3y is equal to 5 minus. No, that's what's done 22. Yeah, this is 22. 5 minus 22, that's minus 17. And yet I get y is equal to 17 over 3. Yeah. So, I mean, you can do it anyhow you want. You okay?
Yeah.
Right. So you see, there's really no need to do substitution. Honestly. What you do that for? You got how to do it for 4, 5, and 6 too. So let me speed run this. So equation 4, we have 1, we have 2. Obviously, I'm gonna use equation 1 to make equation 3. But you want to make the subject?
Let's make y.
Right? So you skipping ahead. Y will be equal to what? I will move across what? So y will be equal to
I equal to b equal to 6 over x. No, what am I talking about?
actually we could do that. Let me try that. Let's try that. Let me do that. So you're saying to use equation 2, right?
Yeah.
Use equation 2 to make 3. So y, say you would have xy is equal to 6. And so I would divide both sides by x to find for y. So y, x, means 6 y x. And that is 3. Right, so that's 3. Okay. And I'm going to plug that into y equation.
I'm gonna plug it into equation 1.
Right? So I'm going to write x and y. I'm going to replace y. Y is 6 over x. And that'll be equal to 5. Now we're here to work with fractions, so I should probably multiply both sides by.
Gonna multiply by 6.
Now what we have in the denominator,
Oh, x.
right? Because remember, if I want to get rid of the denominator, I would have to multiply by x, so it will cancel off.
Oh, yeah.
And so x by x, we're going to multiply everything by x. X by x is?
Nothing.
No. What is x by x?
Oh, x squared.
Right, x squared. What is 6 over x by x?
6 over x squared.
No. Watch. What happened there?
Oh, they're gonna cancel, so it's just only 6.
Right? And on the right-hand side, 5 by x is just 5x.
Yeah.
And so we're going to, remember, we want to put it in the form of our quadratic, which is ax squared plus bx plus c is equal to 0. So it needs to be equal to 0. So I'm going to move across the 5x. And so I'm going to write it in the form one time. Hold on a scale of 1 to 10, how much that confuse you? Like, if at all.
Like 2, not really.
So you understand if I move across 5x, I'm going to turn to minus 5x. And so
Yeah.
I just put it behind the x squared. So I didn't do anything too crazy. And so now we're going to factorize. You should know how it is go by now. And what we had to multiply to get x squared.
X.
Right? So we're gonna say x by x, and we're gonna look at the last number. The last number is 6. So
yeah,
you know, ask yourself how you could multiply to get back positive 6, but add to give you minus 5.
2 and 3.
Okay, but if you add 2 and 3, you wouldn't get back minus 5.
So negative 2 and negative.
Yes. And look how fast you get the answer, like boom. So what value for x would make this first bracket 0?
2.
What value for x would make this bracket 0?
3.
Real easy.
Very easy.
And so we're gonna plug that into equation 3 now to find for x. I mean to find for y. To find for y, right?
Yeah.
Right? So you're gonna say so y is equal to 6 over x. Right? So when x is y would be equal to 6 over 2, which is
3.
Right? So that the answer would be 2, 3. Right? And when x is equal to 3, y is going to be equal to 6 over
2.
3.
3, sorry.
And so y would be equal to 2.
Yes.
So that point would be?
So it'd be 3 and 2.
Right. So if you were to do the graph, right? If you were to do the graph, you would, this point over here, well, I think you kind of see how it'll come out. Basically, it will be 3, 2, and 2, 3.
Yeah.
And if you check it, it will work out, right? Because 3 plus 2 is 5, well, and 2 by 3 is 5, 2 by 3 is 6, 3 by 2 is 6. Works out.
Yeah.
Right? Nice. So, like, you could now do some hard maths questions, and you're not even doing hard maths. So, hell yeah.
All right.
Teach you some hard maths. Because these kind of questions wouldn't come in maths, but it's good to know it in case they decide to be dotish. You know? You never know.
Yeah, because on the last TXT paper, they were very sneaky.
Yep. Let me do this one now. This one go on trickier, tie up a little bit. Let me just speed run it. So we're gonna use the first equation to make we're gonna use the first equation to make equation 3. And we're gonna make x a subject. So
yeah,
x plus y is equal to 9. If I want to make x a subject, move across y. And so x would be equal to 9 minus y. And so that's equation 3. And so I'm gonna plug equation 3 where?
Gonna plug equation 3 into equation 2.
Right. So I'm going to write x squared, which is 9 minus y squared minus y squared is equal to 9. Right? Remember, 9 minus y squared would mean 9 minus y by itself. I'm gonna move across that 9 one time because we're gonna form a quadratic. So it's gonna turn to minus 9.
Yeah.
This. It's gonna be 9 by 9, then 9 by minus y by 9, and minus y by minus y. So quickly, 9 by 9 is 81, 9 by minus y is minus 9y, minus y by 9 is minus 9y, minus y by minus y is?
Minus y by minus y is nothing.
No, you make a mistake again. If you have a negative, it gives you a what?
A positive.
And what is y by y?
Positive. Not positive. 2y.
No?
No, y squared. Ah,
So negative by negative is a plus, and y by y is?
y squared.
Right. Okay, this question gonna be easy then. It's gonna work out to be a very, very easy question. So if you notice you have minus 9y, that goes into minus 18y. We have y squared minus y squared. What is y squared minus y squared?
Nothing.
Nothing. I go and cancel it.
Yeah.
Right. That whole thing got cancel off. Think of it like 5 minus 5. And 5 minus 5 will be right. So this
Yeah.
whole thing gonna cancel off here. And you're just gonna have minus 9. And so you have 81 minus 9. What is 81 minus 9? That should be minus, it should be 72. Check that from 7. And so you want to find for y, right? So you're going to what's that 72. And so you're going to get minus 18y is equal to minus 72. And if I want to find for 1y, I would have to divide both sides by
minus 18.
Right. And so y will be equal. And if my math's correct, I think that should be 4. Like just mentally. Check that for me. That's how bad I think it will be 4.
Yes.
Badness.
Badness.
Right, so y is equal to 4. Right? And if I want to find for x, which equation I should use?
If you want to find for x, you should use equation.
Anytime you do substitution, you should use equation 3 to find for the other unknown. And so x to 9 minus y. Right? And so x will be equal to 9 minus 4. So x will be equal to, what's 9 minus 4?
Right.
And if I wanted to check if my answer is correct, you know how to do that?
Yeah, I know how the bad this come down.
Right? And the answer will be 5, 4. Anytime they ask you to write your answer as a coordinate, this way you do it. You put any x first and any y. So for all the questions we did previously, you could have stated the solution as a coordinate. This one will be 8 over 3, 17 over 3. I think you understand what I'm saying. You just put the x first and the y.
Yeah.
Because we really know what it means, right? What we really find is the pointer intersection. That's what we really finding for. And you know that.
Yeah.
That's why you could write it as a point. Okay, let me just verify the answer correct. So I have 5, 4. So x is 5, y is 4. So x is 5, y is 4. Does it give me 9? 5 plus 4, is it 9?
Yes.
Right? What about 5 squared minus 4 squared? 5 squared is 25. 4 squared is 16. It's 25 minus
9.
Yeah. So we're good, right? Good.
Yeah.
Nice. Last question. We do like we do 18 pages of maths. And not baby maths either. We do some complicated maths here. And you survive.
Yeah. Because for the first time I'm doing maths, I'm not dead.
That's good to hear. So question 6. Obviously we know how the badnesses go. Like we just make equation 3 from the first equation. Simplest thing you could do. And so we want to make this object of the formula.
Only make x.
X, so we know x could be equal to 13 minus y. And I'm going to plug that into equation 2.
So that's going to be 13 minus y times squared, and that's plus y squared equals 85.
So like you think anybody, and from this, you realize that anybody could become good in maths, right? Like once you like understand it, And you do
Yeah.
it. Math's not hard. It's really not. So we're gonna expand this. Okay. Right. So what is 13 by 13?
13 squared.
Right. So that'll be 169. And we have 13. What is 13 by minus y?
Uh, 13 by minus y, that's 12y.
No. What is 13 by y?
13 by y is 13y.
If I had negative 13, that'll be negative, comma.
Negative 13y.
Right. Don't get confused. Don't get tired. Right. What about here? What is minus y by 13? Is the same thing? Minus y by 13 is?
13y.
All right. And then minus y by minus y is?
Minus y squared.
No. What is that negative by negative?
Or positive y squared.
Right. And I'm gonna add a right back the y squared here. Best I just move across our 85 one time. We know how we're gonna play out. And so I have y squared plus y squared. I have negative 13y, and I have 169 minus 85. So I want to put the y squared first. So what is y squared plus y squared?
Wait, 2y squared.
Right? What is minus 13y minus 13y? Imagine you take $13 and you take $13 again. How much money you take?
26.
Right? So that'll be minus 26y. And then lastly, we have 169 minus 85. What would that be?
That'll be
7. No,
84.
84, yeah. Right?
Yeah.
This one looking tough to factorize, but we will see. So we could divide throughout by 2. If I do that, I go and I put y squared minus 13y plus 42. Right? What would I have to
Yeah.
multiply to get y squared?
Y.
What would I have to multiply to get 42? But add to give me negative 13. So maybe a little tough.
2 and 24. No. Yeah. Can I add to get 13? Give me a bit. Let me try to get this paper.
I'll give you a hint. These 7 timetables.
Stick and 6 and 7.
Yep. But 6 and 7 would give you positive 13. So we think it should be.
Negative 6 and negative 7.
Right. Because negative 6 by negative 7 is positive 42. But
Yeah.
minus 7 is also negative 13.
Yeah.
So, right. So tell me, what would y be to make that bracket 0? If y is 1, that whole bracket could be 0. When y is?
So y is so 6,
Right. And when y is equal to?
7.
Right. Those values would make the brackets equal to 0, and 0 by anything is 0. Badness. And so
But
we're going to use equation 3 now. Equation 3 says that x is equal to 13 minus y. And so when y is 6, x is going to be 13 minus 6. And 13 minus 6 is 7, I think.
Yeah.
Right? So that point is going to be 7, 6. And when x is when y is 7, x is going to be equal to 13 minus 7. And so x is going to be equal to,
6.
right? So my point here is going to be 6.
6,7.
Right. So how you feeling?
But
How you feeling like you cover like the whole of simultaneous equations, like even like what you could do in hard maths. It don't get harder.
yeah,
Like it don't even get harder than this in hard maths.
yeah, I feel like I have it now. I just need to like practice.
Well, you could do these questions again, right?
Yeah.
Right? But before we end the meeting, let me just go back to the original definition. Also, guys, enroll today, you know. Let me go back to the original definition. It says simultaneous equations are two or more equations involving four unknowns where the solution is the set of values that satisfy all the equations. Do you understand what that means now?
Yes.
So simultaneous equations are two. Well, we just deal with two, right?
Yeah.
Two equations, and just see that, like literally all of them is two equations.
Yeah.
And two or more unknowns. And you have to find for two unknowns.
Yeah.
And they're saying that the solution should satisfy the equation. Did that happen?
Yeah.
Right. So do you fully understand what a simultaneous equation is?
Yes.
Nice. So would you recommend myself Mathvybes?
Of course.
Nice. So
Enroll today.
the statement does go in Mathvybes we. Let's see if we can finish the sentence. In Mathvybes we.
Vibe to math.
I was really going to trust in Mathvybes we trust. Yeah. But work with that. Right? I will send you these notes. Right? And yeah, until I see you next time, best of luck with the exam. Right? You should be able to do simultaneous equations now and making things the subject of the formula. Because we did that.
Yeah.
So you take care. Have a blessed night. What's the time in Jamaica right now?
10:08.
Oh, in Trinidad is 11:08.
That's pretty late. All right, get some rest.
Yeah. I go on party tomorrow. What do you mean? I go on party. If you come to
Oh,
you might see me,
drink safely.
you might see me in Tobago. If you come to Tobago tomorrow.
All right, peace out.
It's a